เรียนท่านคณะกรรมการ เรียนท่านผู้จัดงาน แล้วก็สวัสดีนักเรียนทุกคนนะครับโรงเรียนมอ.วิทยานุสรณ์ร่วมกับคณะศึกษาศาสตร์มหาวิทยาลัยทักษิณมายองจิ University ประเทศเกาหลีใต้ต่วนกูอับดุลรอมาน University of Management and Technology ประเทศมาเลเซีย Methodist Boys School ประเทศมาเลเซียจัดการแข่งขันโครงงานระดับนานาชาติ International STEM Project Fair 2025 ISTEM ภายใต้แนวคิด Industry Innovation and Infrastructure รอบแกรนด์ไฟนอลวันที่ 10 กันยายน 2568 ผ่านรูปแบบออนไซต์ณโรงเรียนมอ.วิทยาสอนร่วมกับรูปแบบออนไลน์เพื่อเป็นเวทีในการแลกเปลี่ยนเผยแพร่โครงงานงานวิจัยและนวัตกรรมของนักเรียนการเรียนรู้ด้วยการทำโครงงานเป็นการจัดการเรียนรู้ที่เปิดโอกาสให้ผู้เรียนได้ลงมือศึกษาค้นคว้าด้วยตัวเองตามความสามารถความถนัดและความสนใจโดยอาศัยกระบวนการทางวิทยาศาสตร์หรือกระบวนการอื่นไปใช้ในการศึกษาหาคำตอบในเรื่องนั้นๆโดยมีครูผู้สอนเป็นเพียงผู้กระตุ้นแนะนำให้คำปรึกษาแก่ผู้เรียนอย่างใกล้ชิดส่งผลทำให้เกิดความริเริ่มสร้างสรรค์อีกทั้งโครงงานที่ตัวเองสนใจยังก่อให้เกิดองค์ความรู้ที่กว้างขวางอีกทางหนึ่งการจัดกิจกรรม STEM 2025 เป็นการเปิดโอกาสให้ผู้เรียนได้นำเสนอโครงงานในรูปแบบการนำเสนอแบบปากเปล่าการแลกเปลี่ยนเรียนรู้และการเปิดประสบการณ์และแนวความคิดใหม่ๆจากการได้ฟังการนำเสนอของเพื่อนๆต่างๆโรงเรียนทั้งในและต่างประเทศล้วนเป็นกิจกรรมที่ดีและยังประโยชน์ให้แก่ผู้เรียนและผู้สนใจเชื่อว่าความรู้ที่ได้รับจากกิจกรรมในครั้งนี้สามารถนำไปประยุกต์ใช้ในอนาคตต่อไปได้เป็นอย่างดีด้วยความสามารถของนักเรียนในการศึกษาค้นคว้าและการทำโครงงานหลายโครงงานสามารถต่อยอดในระดับที่สูงขึ้นต่อไปและยังคุณประโยชน์ให้แก่ประเทศชาติและสังคมโลกอีกทางหนึ่งกระผมหวังเป็นอย่างยิ่งว่าการจัดกิจกรรม STEM 2025 เป็นกิจกรรมที่ดีและตอบโจทย์การจัดการศึกษาได้ดังดีเยี่ยมและคาดหวังให้มีการตอบรับจากนักเรียนทั้งในและต่างประเทศเป็นอย่างดีเช่นนี้ในปีต่อๆไปและขยายเครือข่ายความร่วมมือสู่ระดับสากลและนานาชาติเพิ่มขึ้นสุดท้ายนี้ก็ผมขอขอบคุณคณะผู้จัดงานทุกท่านและทุกสถาบันที่ได้ร่วมมือกันจัดกิจกรรมอันเป็นประโยชน์แก่ผู้เรียนและผู้สนใจหวังเป็นอย่างยิ่งว่าทุกท่านจะได้รับประโยชน์สูงสุดการจัดกิจกรรมในครั้งนี้ณ บัดนี้ถึงเวลาอันสมควรแล้วก็ผมขออนุญาตเปิดกิจกรรม ISTEM Project Fair 2025 ครับ
ลำดับถัดไปผู้ช่วยศาสตราจารย์ดร.วิทยวัฒน์ ขติยามานคณบดีคณะศึกษาศาสตร์มหาวิทยาลัยทักษิณโดยจะเป็นการกล่าวผ่านคลิปวิดีโอที่ได้จัดเตรียมไว้ขอเรียนเชิญทุกท่านโปรดรับชมทางหน้าจอได้เลยค่ะ
ในนามของคณะศึกษาศาสตร์มหาวิทยาลัยทักษิณขอต้อนรับทุกท่านเข้าสู่การแข่งขันโครงงานระดับนานาชาติ International STEM Project Fair 2025 รอบ Grand Finals ซึ่งจัดขึ้นในวันนี้ทั้งในรูปแบบออนไลน์และออนไซต์ณโรงเรียนมอ.วิทยานุสรณ์การจัดกิจกรรมในครั้งนี้เกิดจากความร่วมมือของหลายสถาบันได้แก่โรงเรียนมอ.วิทยานุสรณ์มหาวิทยาลัยทักษิณมยองจี University สาธารณรัฐเกาหลีตุนกูอับดุลรามาน University of Management and Technology และ Methodist Boys School ประเทศมาเลเซียโดยมีเป้าหมายสำคัญเพื่อเปิดเวทีให้นักเรียนได้แสดงออกถึงความรู้ความสามารถและนวัตกรรมด้านสเต็มตลอดจนเป็นพื้นที่แห่งการแลกเปลี่ยนเรียนรู้ทางวิชาการในระดับนานาชาตินับเป็นความน่ายินดีที่ในปีนี้มีนักเรียนเข้าร่วมมากกว่า140ทีมซึ่งสะท้อนให้เห็นถึงศักยภาพความมุ่งมั่นและพลังสร้างสรรค์ของเยาวชนรุ่นใหม่ที่พร้อมจะเป็นกำลังสำคัญใน ในการพัฒนาสังคมต่อไปสุดท้ายนี้ในนามของคณะศึกษาศาสตร์มหาวิทยาลัยทักษิณขอขอบคุณทุกภาคีเครือข่ายที่ร่วมกันผลักดันให้เกิดเวทีสำคัญในครั้งนี้และขออวยพรให้งาน International STEM 2025 รอบแกรนด์ไฟนอลประสบความสำเร็จอย่างงดงามและเป็นประสบการณ์อันทรงคุณค่าสำหรับผู้ร่วมงานทุกคน
Now it is my great honor to invite our host institution, Myongji University, to deliver the opening remark. The message will be presented to a video special prepared for this occasion. Please direct your attention to the screen.
Hello, students, professors, and distinguished guests who are here today. My name is Jongbin Yoon, and I represent Myongji University, which is located in Seoul, Korea. On behalf of Myongji University, I am honored to take part in international STEM. Thank you, organizers for giving our university a chance to meet with the future scientists and learning researchers as students who are here today and who have exceptional talent and passion for learning. If time permits, I hope you will have a chance to learn about Myongji University, a renowned institution of higher education in the capital city of Korea with 75 years of history during today's competition. Our graduates from college and engineering and natural science, which teach a wide range of disciplines, including more than 10 engineering majors, physics, chemistry, food and nutrition, and biological science and biological information, have been working actively in their professional fields inside and outside of Korea. And we have more than 1,500 international students who are coming from different parts of the world to benefit from our excellent degree programs. If you are interested in studying in Myongji University to acquire knowledge and increase global competitiveness, please feel free to contact us anytime for detailed information. We wish all you the very best for your competition and looking forward to meeting all of you in Korea. Thank you.
Finally, for the last part of the opening remarks, it is my great honor to invite Dr. Katiyani, Dean of the Faculty of Social Sciences and Humanities, to deliver today's opening address. Before we proceed, I would like to extend a warm welcome to Dr. Jesslyn, who is joining us today via Zoom. Thank you for being with us, Dr. Jesslyn.
Good morning and warmest welcome, warmest greetings from Tunku Abdul Rahman University of Management and Technology, Kuala Lumpur, Malaysia. Welcome to the grand finals of the ISTEM 2025. It is an honor and pleasure to be here, and a warm welcome to the student participants, their advisors, the judges, and all those who have worked very hard to make this event happen today. On behalf of Tunku Abdul Rahman University of Management and Technology, we extend our deepest gratitude to PSU Witayonuson School for inviting us once again to be part of this meaningful event. Namely, Takshin University, Myongji University, Korea, and the Methodist Boys High School in Malaysia. Your support has made this global showcase, a showcase of talent, possible. STEM education is important because it equips students with the skills they need to succeed in a technology-driven world, fosters innovation, and addresses critical global challenges. It goes beyond rote memorization by emphasizing hands-on, project-based learning, which cultivates a unique set of skills. It develops critical skills, fosters innovation and economic growth, addresses global challenges, and promotes interdisciplinary thinking. To our exceptional junior and high school finalists, you have reached this stage through your dedication, curiosity, and innovative spirit, supported and assisted by your advisors. You have demonstrated remarkable talent in tackling complex topics across 5 key areas: biology, ecology, biodiversity, applied chemistry, and environmental science, physics, space and astronomy, mathematics and statistics, and technology and computer science. This event is more than just a competition. It is a platform for knowledge exchange and a showcase of young minds on an international stage. You have not only conducted experiments and explored data, but you have also applied scientific knowledge to create remarkable inventions. I hope that all of you will continue to work on various other projects, research, which will benefit the world. Before I end, I would like to invite all of you to visit our campus in Kuala Lumpur, Tunku Abdul Rahman University of Management and Technology, soon. With that, thank you and all the best to the finalists.
On behalf of the organizing team, we would like to express our heartfelt gratitude to all our hosts and partners. PSU Witayonuson School, the Faculty of Education at Taksin University, Myongji University in Korea, Tunku Abdul Rahman University of Management and Technology in Malaysia, and Methodist Boys High School in Malaysia. We would like to thank the representatives from these institutions for the inspiring opening speech. Your valuable insights and encouragement have created a wonderful atmosphere for today's programs. And we truly appreciate your contributions. Thank you all for making this event possible and memorable. This event wouldn't be possible without the esteemed panel of judges. Next, please give a round of applause for the video introducing our distinguished judges.
We would like to extend our heartfelt gratitude to the esteemed panel of judges for their time, expertise, and dedication in evaluating the project.
The moment everyone has been waiting for has arrived. The presentation of projects by all the participants in each room at the International STEM Project Fair 2025, Grand Final on September 10, 2025.
ถัดไปนะคะจะเป็นการแบ่งห้องตามสาขาดังนี้ สาขาชีววิทยา นิเวศวิทยา และความหลากหลายทางชีวภาพ 1 ห้อง 4301 ชีววิทยา นิเวศวิทยา และความหลากหลายทางชีวภาพ 2 อยู่ห้อง 4303 ค่ะ สาขาเคมีประยุกต์และวิทยาศาสตร์สิ่งแวดล้อม 1 ห้องราชพฤกษ์ สาขาเคมีประยุกต์และวิทยาศาสตร์สิ่งแวดล้อม 2 ห้อง 3310 สาขาฟิสิกส์และสาขาวิสิกส์อวกาศและดาราศาสตร์ห้องชัยพฤกษ์สาขาคณิตศาสตร์และสถิติห้อง 4201 ค่ะ สาขาเทคโนโลยีและคอมพิวเตอร์ 1 ห้อง 4401 สาขาเทคโนโลยีและคอมพิวเตอร์ 2 ห้อง 4403 การนำเสนอด้วยภาษาอังกฤษ 1 ห้อง 4401 และการนำเสนอด้วยภาษาอังกฤษ 2 ห้อง 4407 ค่ะ
สำหรับการนำเสนอในปีนี้นะคะกติกาการนำเสนอแต่ละกลุ่มมีเวลานำเสนอทั้งสิ้นไม่เกิน20นาทีแบ่งเป็นเวลานำเสนอ12นาทีและตอบคำถาม8นาทีค่ะในกรณีที่ผู้เข้าแข่งขันใช้เวลาในการตอบคำถามใช้เวลาในการนำเสนอน้อยกว่า12นาทีจะทดเวลาที่เหลือให้เป็นการตอบคำถามจนครบ20นาทีค่ะรูปแบบการจัดงานจะมีทั้งแบบออนไลน์ผ่าน Zoom Meeting และแบบเข้าร่วมสถานที่จริงณโรงเรียนมอ.วิทยานุสรณ์สำหรับผู้เข้าร่วมแบบออนไลน์ครูประจำห้องของแต่ละสาขาจะดำเนินการนำทุกท่านเข้าสู่ห้องนำเสนอส่วนสำหรับการนำเสนอแบบออนไซต์แต่ละสาขาจะรวมตัวกันบริเวณหน้าห้องราชพฤกษ์และจะมีเจ้าหน้าที่จากแต่ละห้องคอยอำนวยความสะดวกในการรับผู้เข้าแข่งขันเข้าสู่พื้นที่นำเสนอค่ะสำหรับวันนี้พวกเราขอส่งทุกท่านเข้าสู่การแข่งขันการนำเสนอได้เลยค่ะขอบคุณค่ะ
โอเคนะเดี๋ยวเราจะไปนำห้องต่างๆนะคะมันมีสาขาเดี๋ยวต้องให้รู้สาขาตัวเองใช่ไหมครับตอนนี้เนาะมีครูประธานไปโอเคนะถ้าแค่เก็บกระเป๋าเก็บของต่างๆไว้นะลูกนะโอเคไหมกันนะคะคณิตศาสตร์เราต้องให้คุณมาเรียนคณิตศาสตร์นะคะ
Hello.
Testing, testing, testing audio. เออสวัสดีครับอาจารย์ธวัฒน์
อาจารย์ทิพนิชสบายดีนะครับ
สวัสดีครับผมสวัสดีครับผม
สวัสดีครับสวัสดียามเช้าครับ
พอดีผมมีไอเดียมานำเสนอคณะรอ ผมว่า
อ่า
ทีมทีมที่ได้รางวัลชนะเลิศที่1นะครับ น่าจะขอให้เขามาพรีเซนต์อีกรอบหนึ่งแล้วก็อัดวิดีโอไว้แล้วขึ้น YouTube โปรโมทของโรงเรียนนะครับ
อืมฮึ
เอาขึ้น เฉพาะที่1ที่ได้ชนะเลิศนะครับ
ครับผมเห็น
จะ
ด้
ได้
วยค
เก็
รั
บบ จะได้เก็บไว้เป็นแบบว่าโปรไฟล์ของโรงเรียนเวลามีงานมันก็ขึ้นผมว่าครับผม
เห็นว่าทิศทางของ Presentation เนี่ย มันไปทาง AI เป็นส่วนใหญ่แล้วเดี๋ยวนี้
อ๋อครับจริงๆ testing เดี๋ยวผมขออนุญาตไปกินขนมแป๊บเดียวนะครับ
ครับผมครับผม
สวัสดีครับอาจารย์ทิปนิชอาจารย์ธวัฒน์ห้องนี้ SP1 อาจารย์อยู่โอเคอาจารย์ทั้งสองท่านอยู่แล้วขออนุญาตทดสอบเสียงอาจารย์ได้ยินเสียงผมไหมครับ
โอ้ชัดเจนเลยครับ
โอเคได้เลยครับเดี๋ยวขออนุญาตเป็นเวลาเตรียมตัวให้นักเรียนสักครู่หนึ่งนะครับ
ครับผมได้ครับ เริ่มก้าวตรงเลยใช่ไหม
เริ่มช้าผมก้าวตรงครับอาจารย์ทิปนิชได้ยินเสียงผมไหมครับ
เมื่อกี้นี้ผมคุยกับอาจารย์พิมพ์อยู่แกไป
อ๋อโอ
ขอ
เค
แวะกินขนมอยู่
โอเคได้เลยครับได้เลยครับได้เลยครับโอเคครับเดี๋ยวเริ่มก้าวตรงครับ
โอเค
Good morning.
Good morning.
Good morning, ladies and gentlemen, distinguished judges, participants, and honored guests. Welcome to the International STEM Project oral presentation at ISP School.
My name is Ratia Sangsomun from Mathayom Siksa Post/1.
And my name is Kurina Tracy from Mathayom Post/1. We are the MC for today. Good morning, everyone, and welcome to the oral presentation for the International STEM Project. We are thrilled to have you here today as we showcase the innovative and inspiring projects developed by participants from various fields of science and technology.
Today, we will discuss test research, creative solutions, and simple content. That's how the most model. And we are confident that this presentation will spark and inspire other participants. Without further ado, we can participants the best of luck and encourage everyone to engage actively in this exciting event. Thank you.
Allow me to introduce our distinguished judges, committee members who will be evaluating their presentation today. Associate Professor Dr. Thawat Chitrakan, Doctor of Philosophy in Nuclear Physics from Kent State University, USA. And Associate Professor Dr. Tipanit Chasio, Lecturer at the Department of Physics, Faculty of Science, Naresuan University, Thailand, and doctoral that combined Master's and Doctor of Philosophy degree from Purdue University, USA.
Start live for project presentation. Number 1, present in English. Number 2, the presentation time is limited to 12 minutes, with an additional 8 minutes per question from its judges. If the presentation is shorter than 12 minutes, the remaining time can be used for answering questions up to a total of 20 minutes.
Now, let's move on to the exciting part of today, the presentation itself. We'll introduce the competing project one by one, and our first team is now ready to present.
Please give a warm welcome to Team IST4.
Team ISP4 is presenting a project titled Deep Learning-Based Heart Murmur Classification from Photocardiogram Signal.
They are represented by Demonstration School of Prince of Songkhla University, Secondary Thailand. The researcher is Siri Kusama.
Let's encourage Team ISP4 as they begin their presentation. Yeah.
Good morning, everyone. My name is Good morning, everyone. My name is Siri Kusama, and I am the Demonstration School of Prince of Songkhla University. Today, I am honored to present my research project, titled Deep Learning-Based Heart Murmur Classification from Photocardiogram Signals. Today, in this project, I designed a system that uses AI specifically deep learning to detect heart murmur from heart sound recording. I also developed a web application that allows users to upload heart sound and receive instant analysis. I will walk you.
Could you slow down, please?
Okay. I'm sorry. I will walk you through the problem, objective methodology, research, and the potential real-world application of the system. Okay, this is our introduction. According to the World Health Organization in 2016, cardiovascular disease were the leading cause of death globally, causing over 17.9 million deaths per year. In Thailand, the problem is just as serious. In 2022, heart disease cases an average of 6 deaths every hour. The challenge is that detecting murmur requires high expertise. Many general practitioners or medical students may not have the experience to recognize them correctly. The problem is even worse in rural area where there are no cardiologists at all. So we need a system that can help detect murmurs automatically, quickly, and accurately, and that's where AI coming. The project has three main objectives. First, to develop a deep learning model that can classify heart sound as either normal and murmur. Second, to create a web-based application that is simple to use, accessible for everyone, not just medical professionals. And third, to evaluate the model performance using machine learning metrics such as accuracy, precision, recall, and F1 score. Next is our methodology. Let me explain the methodology step by step. First, data acquisition. I use an open source dataset of PCT recording which contain both normal heart sound and murmur clusters, labeled by expert. Second is processing. How sound data was processing using FFCC. FCC is commonly used in speech recognition. Frequency-based filter that can represent to characteristics of the sound. Next, model development. I designed a custom model combining CNN and ISTM layers. The CNN layers detect spatial patterns of FFCC spectrogram, and the ISTM layers learn temporal scales, how the sound change over time. Next is our training and evolution. We use simulation to make the evaluation reliable to avoid overfitting. And at last, the deployment. The plan module was deployed using Python web framework. It was then integrated into a web application, which I will show in a moment. Yes, let's take a look in. Sorry, this is our web application. At first, I will upload the PCB and I will get results the web and tell me that is the normal case or the normal case. This is our result. The model achieved an overall accuracy of 83.5%, which means it correctly classifies more than 8 out of 10 tests. The model for normal heart sound, the result was 1.00, which means it correctly detects all normal cases. In the comparison with for the normal sound, the result was 0.29, which is still good, but it shows that model is abnormal test. Its confusion metric, characterize the correct and incorrect prediction. As you can see, the model performed very well for normal case, but there is a improvement with murmur. On the right, I have included the chart showing position report and it was all for broadcast. Overall, this results suggest that the system can be used for screening purposes and has the potential to support doctors in their diagnosis. This is our discussion and limitation. The mistake of this system is that it's fast, effective, and doesn't depend on human coding skill. However, it has some limitations. First, The dataset used limit in size, specifically in kilometers a second. One can vary greatly in time and intensity, which make them harder to detect with a single model. In the future, the model will from more more diverse real data, especially from professional and real papers. This is our benefit and future application. Despite in its limitation, this system has many possible applications. It can support doctor viewing card set up by providing second opinion. It can be used in rural area where no special rights are available. It can serve as any tool for students to practice listening to sound. In the future, it can to improve the system by collecting more sample and testing in the real clinic, and eventually mobile app version for easier user. That concludes my presentation. Thank you very much for your attention and your interest in this project. I'm happy to answer this question you may have.
Next, we would like to proceed with questions and recommendations from the committee members.
May I invite Associate Professor Dr. Tuan to give advice and answer.
Yes, your project is quite interesting.
Thank you.
I have the one question that when you first start the project, how you can classifying the sound as normal or murmur, hard sound?
Okay, you can see that this is not the example sound of murmur. In the realm of
Your microphone is not. I can't hear you.
you hear me.
Yes, please. The sound is quite.
Okay. Hello. You hear me?
Hello. Okay.
Okay. Murmur is a sound that happen when your heart have smaller than the normal heart. Is this true? This is the sound of the sound. This is the normal sound. It's easy in the child, so I use this to see that's normal or normal.
From your result, you said that the initial test, you can achieve about 85.7% accuracy.
Yes. Yes.
And how you get this number?
From the model train validation, and I don't. But you can see in the results in representative. You can see that in case of number, I predict all of them accurate, but in the case of number, I predict one is not correct.
And for what you plan for the future for this project?
It can develop to be a key possible use in remote areas. Now the very expensive. This model to be developed to be a key for a small hospital in remote area, and it can use for medical student for teaching about the
In Patani, you can find experts in the heart disease from the hospital or not?
No, not yet.
Not yet.
Yeah.
And you should find or invite some medical doctor to be to work to join with you.
I asked when I researched the information, I asked two medical students for the information. This is very difficult to listen. I use that information to develop model.
Okay, that's now. Okay, I would like to hand on the microphone to Dr. Tipanis. To Ajahn Tipanis, please.
Okay, thank you. First, I was quite surprised that you did this research all by yourself, and so I have a few questions, if I may. First question is that how did you acquire the data set, the training voice file?
There is a lot of file in a lot of medical website use on that, and it's in the reference.
I can't hear you very well. Maybe if you can.
Sorry. Okay. I got them from a lot of medical websites, and I like the website in the reference. In the presentation, I put it in my research.
I can't make out your answers. Is it from hospital or someplace or the internet?
Yes, it's from internet, from the medical website.
Good. So you took this data set from the internet, and how many set did you have?
I have 900, more than 900 sets.
Okay. So you have a huge data set of this murmur sounds of the heart as it pumps the blood. Okay. All right. I guess the accuracy that you got, 85% accuracy, is in a typical range. So my next question is that can you explain to me what the LMST, I forgot what the kind of network that you were using. So there was CNN and LSTM. So what is LSTM network?
LSTM is long-term memory. It's used for temporal sequence. My sound, yeah. For use it can generate it also in
I can't hear you again. Could you stand
Okay.
next to the microphone? Thank you.
Can you hear me?
Yes, that's good now.
Okay. LSTM is long-term memory. It's used for when you generate the answer in the time graph. So no, but it used with CNN or conventional neural network that can read my graph from newspaper program. Yeah, and the graph is from the graph have the time and CNN STM when you work with the time in my graph.
Okay. Oh, that's all right. But I only got bits and pieces of the answer because of the sound was not good. But I think I got the answer. That's all the question I have for now.
Thank you very much.
Thank you very much for your questions and valuable questions. We let's move on to ISP14. First of all, ESP, UV, and air purifier.
Represented by Kun Pin Tia Kun Steve Thailand, researcher of Onsite of the and Dana.
Yes. Just encourage ISP14 as they begin their presentation. Everyone. Oh. Hey, Pumpkin, if you're ready, you can start.
I'll start. Okay. Awesome.
Good morning. My name is Chitadipa. My name is Supanan Mungtakul.
My name is Pianat Nityamansi.
Today we will present our project, the portable ESP8 UV amplifier, designed to reduce PM 2.5 and improve indoor air quality.
So, introduction. Thailand is currently facing serious issue related to particle matters PM2.5. These airborne particles are smaller than 2.5 micron. That's about 3 times smaller than human hair. The Pollution Control Department has reported PM2.5 level exceeding health students due to close weather conditions and other contributing factors such as smoking, vehicle emissions, a burning activity, including garbage. This activity generates a fine dust and unpleasant odor that are harmful to human health, as a particle can penetrate to lung and enter bloodstream through the respiratory system, leading to cardiovascular increase, lead through to irritations in various parts of the respiratory tract. To address this issue, this project developed such a solution in form of a portable ESP air purifier that remove airborne, thus using a multi-state filtration system combining an electrostatic precipitation or ESP for the fine particulate removal and activate carbon filter for odor and gas absorption, and UVC light module for micromal disinfection. This device does not include an generate sensor for that measurement, but focus on efficiency filtration to find a particulate matter to protect individual and community health by reducing risk associated with air pollution, particularly from PM 2.5.
And this is external structure of our purifier. This is the internal structure of our purifier, and this is the main components. For working principle, the dust particle will be stuck in from this way.
Could you slow down, please?
Oh, okay. Sorry. The dust particle outside will be stuck in from this way and meet the cross filter sheet. After that, the small dust can pass through the cross filter sheet, will meet the stainless steel sheet connected to the negative pole. After that, when the dust receives electron from the negative pole, the dust will meet the copper sheet. This connected to the positive pole, causing them to stick together this area. Yes, after that, the air will meet the activated carbon filter sheet that help reduce odor, and then meet the UV light that help kill germs. The clean air will be stuck out from this way.
The next part is the methodology. One experimental design. One part one chamber testing 0.2 cubic meter. A seal test box 0.2 cubic meter simulate a small enclosed with space elevated PM 2.5 level. Incense smoke was introduced to raise PM 2.5 concentration. The possible ESP UV amplifier was activated. PM 2.5 reduction was measured using a standard external PM 2.5 measuring device.
1.2 classroom testing in 144 cubic meters. Experiments were conducted in the real classroom under 3 different conditions. Case 1, portable XP air purifier in use. Case 2, static air purifier. Case 3, no air purifier. Each test ran for 60 minutes. PM 2.5 level were measured using a standard external PM 2.5 measuring device placed at the center of the room.
And for methodology 2, data collection, PM 2.5 measurement in the chamber. To test our purifier, we first burn incense in the sealed chamber for 1 minute to rest.
You're speaking too fast again. Slow down.
Sorry. To test our purifier, we first burn incense in a sealed chamber for 1 minute to raise PM 2.5 level. Then we activated the purifier to measure the PM 2.5 concentration before and after using a calibrate device. We repeat this process 20 times and calculate the average result with standard deviation to ensure reliability.
2.2 PM 2.5 measurements in classroom. PM 2.5 level were measured using in the same standard external measuring device. Initial PM 2.5 concentration or control between 30 to 35 microcubic meters before each trial. Each trial lasts for 60 minutes under consistent environment conditions. 2.3 Student health monitoring. Health info will record daily over 30 days using a structured questionnaires. Data was controlled for 1 month before and 1 month after using the air purifier.
3. Data analysis evaluate reduction in PM2.5 concentration before and after air purifier use was calculated. Student health data was analyzed by calculating the evaluate number of daily symptom report for each scenario. This is a real classroom to testing. It's 144 cubic meter. For discussion of air purification efficiency in a small chamber of 0.2 cubic meter, the PM2.5 dropped from 999 to just 17 microgram per cubic meter within 30 minutes, showing that very high efficiency. In a larger room, 144 cubic meter, the level without purification was 32.55 microgram per cubic meter, and with our portable ESP1 UV air purifier, it's decreased to 13.36 microgram per cubic meter. This result shows that our purifier works well in both small test chamber and the larger room. Yes. Impact on student health after using the ESP1 UV air purifier, cases of cold and respiratory symptoms decreased significantly. This suggests that lower PM2.5 reduce respiratory irritation, supporting the link between air quality improvement and better student health. Confirm that our PM2.5 air purifier is effective not only in reducing dust but also in promoting health benefits. For conclusion, the portable ESP1 UV air purifier efficiency reduce PM2.5 and really help with in an especially sustainable for confined space such as classroom and homes. Shows strong potential for future commercial application. Thank you very much for your attention. Thank you.
We would now like to invite Associate Professor Dr.
Tiffany Tajio to suggestion and
Okay, let me begin asking questions. But first, my impression on the presentation. I feel that when you were presenting this this research, the person on the left and on the right was kind of reading from something instead of talking to the audience. I think the person in the middle did a good job in presenting, but somewhat too fast. Okay, so when you present these things, you should be telling a story, not reading something to the audience. Okay, think about telling a story to a kid, something like that. And then here's my question. I have seen a lot of model for air purifier, and you is one of them. So how does your model different from other models in the market?
I think it's about ESP. Yes, ESP is a one technology that can reduce PM2.5 is good. Yes, and ESP is not have the trash or something that dangerous about natural about like ESP is the one thing that good to reduce PM2.5.
So from your answer, you said that the ESP is
Yes.
good, but I don't know what ESP is. So if you could slowly explain to me in simple words what ESP is, what
Okay.
it stands for.
ESP as electron reciprocator.
Okay.
Electron reciprocator is have stainless is have negative pole, and copper it have positive pole. That when the when it does receive electron from negative pole, it will stuck when it's stuck in the copper. It is have positive pole. That how reduce the dust. Yes.
Okay, thank you. So my last advice is that when you practice, because I've seen you practice a lot for this presentation, make sure you don't read to the audience. Okay, try to tell a story of your research instead, not reading.
Okay.
All right. Yes.
What introduction?
So, it's about introductions. In Thailand is facing it's a PM2.5 that I was talking about. It's made from dust, burning, smoking, vehicle emissions. That the PM2.5 can PM2.5 can enter the bloodstream. That will make people sick, and that's why we wear masks. For this I sure we made about this project, develop this project to solve this problem.
Okay, thank you.
Thank you very much for
Invite Associate Professor to
Yes, I have two questions. For your experiment, for the small box, for the CU test box, I understand that you take about 30 minutes to reduce the PM2.5 from 1,000 microgram per cubic meter to 17 microgram per cubic meter within half an hour. But for the real classroom test, you didn't tell the condition because the small box you seal it, but for the real classroom, that is very huge volume. The air inside. You didn't tell that the condition of that room is sealed or not, because you used only about 50 minutes to reduce your particulate. Yeah, in the real classroom. And this is, you didn't tell the condition that the classroom to be sealed before you measure the particulate 2.5 or not.
When I test in the real classroom, we seal the classroom. We close the door, and there is a classroom, like and when we test it, we measure the PM2.5 level is what, but 32.55 microgram per cubic meter. And when we activated the air purifier with a portable air purifier, and this used the time for 52 minutes. Yes, and the PM2.5 level that dropped from 32.55 microgram per cubic meter decreased to 17 microgram per cubic meter. Yes.
And another point, you compare between the commercial air purifier and your project. The very important condition is flow rate, because you didn't. I try to look in your literature. You didn't say about the flow rate of the compare between the commercial one and your machine that is comparable with the air flow rate, the inlet of the air flow rate. Can you tell me that what is the condition of the air flow rate be compare between your machine and the commercial one?
ก็คือบอกว่าของเราต่างก็ยังไงต่างกับที่มีตลาดยังต่างกับที่ไม่มี
In a general air purifier, it uses HEPA filter. Yes, and our purifier is use ESP that don't have the trash from when we use the ESP air purifier. When we use HEPA filter, it will have it will have filter, and is the trash, and it's about is dangerous for it's like a trash in the world. Yes, and ESP is don't have a trash, don't have filter. It have styrolate and copper, and we can take it to clean and take it
back
back. Yes.
When you start the experiment, you put your machine in the center of the room or in the corner or somewhere?
In the corner, actually, we test in the room is 144 cubic meter. We test progress 20 times. We swap the this corner and at the second we move in the other corner, and yes.
I understand that what they call the particulate 2.5 in the room is not homogeneous. It I think it's quite fluctuate between the center or the corner or near the window or something. I think that's why if you use what you call the air flow rate in to suck the air into your machine, even though it's you said that your technique ESP is do try to trap by electrostatic, but if you have if the what you call the air is not full pass through that area, it cannot work because the high voltage is not that high that can what we call attract the particulate to the what they call the anode or cathode of your machine, right?
Yes.
ถ้าสมมติเป็นแต่ละการออกไปประมาณการวิธีประมาณนี้ว่าดูถ้าเต็มแล้วเข้ามาเล็ก
Another point is you try to clarify that your machine can reduce the number of students with have a cold.
Yes.
How you know that the cold is the particulate can cause the cold only. It can form other symptoms as well.
เขาถามว่านี่ไม่สบาย we have daily questionnaire like to ask student when we test for 1 month in the real classroom student like 30 people and we random to ask daily question like do you have cold, do you have cold, or are you sick, like and then weถามแล้วก็คำว่าช่าง and ประมวลผลคำว่าช่าง and then we
questionnaire. That's what we use.
พูดให้หน่อยบอกว่าเราถามแบบสอบถามก็นำมาประมวลผลว่าเด็กเป็นไข้เปล่าพูดให้
So we make the poll in Google form and take it to generate to check or have someone sick or like in our school we have the system that tell the teacher about have someone sick or someone is not good or
yes like that and
So I would like to suggest that to improve to the final outcome for this project, try to avoid to use the questionnaire of the student health condition because you cannot control the health condition of the student because you should just only to compare before your machine efficiency before and after you use your machine. That be good enough. If you try to correlate with the health of the student, it will more complicated and reduce your objective topic. I think that you should avoid in this part because it not help your project at all.
Actually I think it's like a test vaccine, like we can control the okay.
Okay, for final, that is what is your future plan?
The future development, we think we will add to the monitoring or mobile control, like on, off, or and have IoT, but it's like to like have notification to user, like have message on Telegram. Yes. Yes. Like.
Okay, good job and go on.
Thank you.
Thank
Yes,
you very
that's
much for
all.
your questions and valuable suggestions. It's time to move on to the next team, ISP18, Skin Disease using Machine Learning.
They are represented by Prince of Wales Island International School.
Yes. Now that they are here, let's give them a
Welcome to
welcome.
ISP18.
ISP18. You guys may start.
Can we wait for two of the members? Because like we are from different place right now.
Okay.
Okay, I'm telling
Good
them.
luck.
You also have to open your camera, by the way.
Okay.
I think you meant turn on the camera.
Can you add one of my friend, like my member, onto this breakdown room?
Wait for a minute.
Yeah, give us a minute.
Can we start now? Oh wait, I will let my friends share the screen.
You may start whenever you're ready.
Okay.
I'm very curious as to where Prince of Wales Island International School is.
Oh, it's in Malaysia. I'm studying
Oh,
here.
okay.
Yeah, but I'm fully Thai. Okay, we can start now. Hi, judges. We are ISP 18. I am Narashaton Rujirattamnamru from Prince of Wales Island International School.
My name is Felicia Punde from Omnoy Soponshunupatham School. Skin diseases are a common problem to tropic regions like Thailand. Regions form cellulite and integral to ringworm, nail fungus, chicken pox, and shingles. If not diagnosed early, this condition can become severe and lead to complications. Recent data also show a rising number of patients, which emphasizes the need for better screening tools. Next slide. To address this, we developed the skin model using machine learning with VGG16 to classify 8 types of impression skin diseases from images captured by a smartphone or digital camera. This innovation supports preliminary screening for both true public and healthcare workers, help reduce specialist workload, and enable early diagnostic and promote better skin healthcare in communities.
Our model detects total of 8 skin diseases. Next slides. The first part of preparation to select the data sets. The data set we used are from online source called Kangol. Total images of 1,200 categorized into 8 classes. After that, we divide the data sets into 3 major groups. Training, we use this to train the model, allowing them to learn the pattern of each skin diseases. 2. Validation, we use this data set to make sure the model actually learned the right disease. 3. Testing, we use this to test the accuracy of the model. Next slides. For the architecture, we use a pre-trained model called VGG16. Previous research has shown that VGG16 is highly effective in clinical image classification, while also being simple and accessible to implement. We then applied transfer learning, which means we adapt the pre-trained data module to our data sets. To reduce overfitting, we also use data augmentation techniques, include rotating, cropping, enlarging image to introduce variation. This is the research paper we found. They compared 3 modules in total. The VGG16 provide the highest accuracy of 0.78%, while 2 of the other model provide 0.66 and 0.69%. So here is our transfer learning steps. So we add our data sets into our module. We also implement data augmentation to promote the variation of the images to prevent overfitting. We trained the module total of 50 times, and our weighted accuracy is at 94.8%. In development of our application, we choose to use Guide App, a platform that allows us to bring the application quickly without heavy coding. The main functions of our apps are as followed. First, the user are required to log in so their usage history can be recorded and tracked. Next, the user can upload images of wound or skin conditions. The system then compared the images to our AI-trained database, which database on machine learning model designed to classify common infectious skin disease. After that, the app provides risk assessment results, along with symptoms and key signs that help user better understand their condition. In addition, the app offers basic care recommendation and even suggests nearby hospitals or clinics, ensuring timely treatment for the user. Therefore, the Therefore, our applications serve as a bridge for preliminary screening powered by machine learning. It not only increased access to healthcare for people in remote areas with limited medical staff, but also act as essential assistance for doctors. Initial screening ultimately support more effective skin health care. We also made the results into training and validation accuracy and loss graphs. The graphs show that the more time we train, the higher accuracy, while the loss also decreases as our time of training increase. We also made the confusion metric. The training accuracy approached nearly 100%, while validation accuracy remained high and stable. The true positive rates consistently exceed false positive rate and false negative rate, reflecting reliability classification performance. Analyzed for confusion metric reveals that the model accuracy classified most disease categories. However, there's some misclassification occurred between visual similar condition, such as lumbar migraines being confused as leaks food. This highlights the potential area for improving by expanding the data sets or refining processing techniques. The Skinly application successfully integrate the AI module to provide real-time disease detection through smartphone images. In conclusion, Skilly is an innovative application utilizing the machine learning to accurately and conveniently classify 8 infectious skin diseases via smartphone images. The model performed well and suitable for community level preliminary screening. Nonetheless, the further development of the dataset and processing methods is recommended to improve accuracy and for similar disease classes. Expanding real user testing is also enhancing user experience and app reliability in the future.
Just say thank you.
No, okay, sorry. In the future, we plan to increase the quantity and diverse of the image data sets so the model can learn different characteristic of the disease, including different lighting condition and then camera angles. And we will able to use the explainable AI techniques such as like grand cam or heat map to test whether the model is focusing on the right area of the images. Thank you.
Now we would like to proceed to the questions and recommendations from the judges.
May I invite Associate Professor Dr. Thawat Chitakan to give advice and ask questions.
Okay. Your project is quite interesting. I have two more questions. If I think your image sometimes is quite similar, like the ringworm or the cellulitis image, how you can classify the difference between the two?
We can it's actually true that both or like some of these diseases are similar, so we could be training with more data set to include to increase accuracy as well. Yeah, and then we can include like other images from other region such as like American country or like more Asian country, because like each country has like different skin texture or skin type. So we would try to cover every skin type to increase the accuracy of the model.
And do you plan to have or invite the medical doctor, the skin medical doctor, to advise your project?
Yes, we're actually thinking about that. So if we really want to use it in the real world application, so we could ask some of the patients with their consent to be able to test our model and gather their feedback for our suggestion on what features could be included to our app or what other diseases they want to include as well.
You mentioned about the smartphone, the Skinny. Is it available now?
Currently not yet. It's being in the development process.
Oh, okay.
Yeah. But we have the prototype.
Oh, you have the prototype.
Yeah.
And now you have about 1,200 images, right? To use to train the AI.
Oh, yes, that's right.
And you plan to increase to acquire more.
Yeah. I think we at least need like 1,000 images per diseases to make
Per
it more, yeah, per diseases for higher accuracy.
Oh, that almost 10,000 images that you needed.
Yeah.
So that is 1,200 images that available is at this moment or in the library.
Sorry?
For the AI model that you train, you use well 1,200 images. Is it available now? Is it available from somewhere?
Yes. Our images are from the online sources called Kangol.
Oh,
Yeah,
from
so
Kangol.
yeah, so I think if we can find the other like data set like sources to provide us, we can actually increase the images number. Yeah. But then we also like use that data augmentation techniques like cropping the images, so we will have more variation to train the AI.
And in the near future, you plan to have some clinical validation or not?
Yes, I guess we could maybe contact like a hospital or a small clinic, whether we can try to use our app and then test and then see how accurate it is, or like how our user are likely to use it and rely on it.
Okay, that's all for me.
Thank you.
Transfer the microphone to Dr. Tiffany.
Oh, it's my turn now. I'm from Malaysia and the other from Thailand. Yes?
Yes, that's
Can you hear
right.
me?
Yes.
Okay. So I am curious to know how do you collaborate? How do you work with each other from different country and all?
Oh yeah. So basically we were like friends, so we were like curious and we wanna like start a project, and then we all like our work style was like kind of similar, and we like do it online call, online meeting, and then do like some discussion, mostly online. Yeah.
Okay. So mostly online collaboration.
Yes.
Interesting. I have another question about the cackle. That is the source of your data
Yeah.
most of the time. How do you know that the cackle is trustworthy? That it's actual authentic medical data for you to use, and not some random AI generated information.
Oh yeah, we actually found that Kaggle was used by like many people, and it doesn't only like provide the images, but also like the coding for other type of stuff too. Like there's not only like medical images, but then there's also data sets maybe like about environmental or like images of like the trees and stuff like that. So that's like widely used in the world.
So it's quite popular database for AI. Okay.
Yeah.
I have one recommendation. If you could show me the research objective slide again.
Okay. I'm not sure if I can present it, but okay. Go to the third.
I forgot what the number of the slide that was, but the title was Research Objective.
Yes. Yeah.
Okay, this one. So my recommendation is the following. When you present something like this, you should put just the icon, like 4 icons on the slide and keywords only. Don't put the whole paragraph in the slide. Okay. The next things I want to ask is my quiz questions. So you use what we call the VGG16 model of the image classification. So could you explain to me briefly what the VGG16 is?
So it basically has like a data sets pool, and then they will like how do you call it? They will like extract the part of the images and then compare the similarity of the images of the like area of their focus. So it has like in total of like 16 box like face, I would say.
Okay, I am not convinced that you understand what it is. Let's go to the detail of the VGG16 architecture, perhaps the figure 1 of your report. And there is one keyword there that you use in the slide. It's called conv. So what is that? What is conv keyword? What does it stand for and what it means?
I'm not quite sure.
Okay, that's fine. You just say you don't know, and that's okay too. So I guess what I'm pointing out is the following. There's a lot that you don't know about the AI. And because you're still young, that you can learn more about the architecture of the image processing. So I would love that you would try to understand deeper, and not just the application part of the AI, but the actual know-how of the processing. Okay, the conv means convolution, and is some technique in AI. I think I know that the platform that you use was a TensorFlow from Google Collaboration. Was that correct?
Yeah, that's correct.
Okay, and I guess my last comment is that when you put that skin test in the mobile phone, I don't think it's a good idea to track the user. Nobody wants to have their identity revealed about their skin problem. So maybe you could make it anonymous skin check as opposed to just tracking user for your application.
Yeah, because like our tracking from what we meant was like maybe, for example, skin disease are like develop like most of the time. So if they take a photo, for example, like yesterday and then yesterday night and then today, so we can compare how much does the disease like progress on like, yeah.
Okay, which bring me to another question. Have you tested the app on the actual skin image? Maybe your friend's skin, or skin with what sunscreen on, or something like that. Have you tested with the actual human image of the skin?
Currently not yet.
Okay. or skin with pimples, something like that?
We haven't tested in real human as well. It's just preparation phase for not right now. Yeah.
Okay. Thank you.
Now let's move on to team ISP5.
Yes, IST5, deep learning model for brain tumor volume calculation from MRI images. This ISP05.
Please come on, welcome to team.
ขออภัยนะครับตอนนี้กำลังถ่ายเปิดพรีเซนเตอร์อยู่
ISP5 can start when you're ready.
So we can start. Okay. Can you see our slide clearly?
Yes, it's shared clearly. We can see it.
Okay. So, good morning, all committees. My name is Methaporn Singhawanakul.
And my name is Napoleon Jiratashuk.
We are from PSU Research on School, and we are presenting deep learning model for brain tumor volume calculation from MRI image. To begin, let's talk about why this is so important. Cancer is a major health issue in Thailand. For instance, we lost 232 people to cancer every single day. When a patient is diagnosed, doctors need to know the tumor size to plan the best treatment. This process, as shown here, involves an initial consultation, evaluating the cancer, planning treatment, and then providing ongoing care. Right now, measuring a tumor is often done manually by doctors. They look at each MRI slice and draw a line around the case, a process called manual segmentation. This can take up to 30 minutes or even longer. Our goal is to change that. We want to use AI for automatic segmentation, making this process much faster and more efficient.
So let's talk about methodologies. To effectively handle the high-dimensional nature of 3D medical imaging data, we employ a patch-based learning strategy. So the original volume are partitioned into smaller blocks and then organized into structured data store to facilitate efficient training and validation. Our model architecture consists of sequential components, including convolutional layers, ReLU exploration functions, batch normalization, and upsampling layers, forming up a typical encoder-decoder structure for segmentation. And our final layer is a pixel classification layers tailored for semantic segmentation tasks. So what is convolutional layers? So instead of looking at the entire image all at once, they scan it piece by piece using a small filters. Each filter searches for specific patterns such as edges, curves, or textures. The crucial point is that convolutional layers don't treat pixels in isolation. They capture the relationship between pixels, which is essential in medical imaging. For example, a tumor is not defined by a single pixel, defined by how group of pixels works. As the network gets deeper, this layer progress from detecting small features such as lines and edges to something more complex such as organs. This allows computer to see medical image in a way that is structured and meaningful, similar to how radiologists interpret CT and MRI. Once these features are extracted, the ReLU activation functions come into play. ReLU is very simple. If the value is positive, keep it, and if it's negative, set it to 0. This small step gives the network two big advantages. First, it helps the model focus on meaningful signal while ignore noise. And second, it speeds up the learning process and allows the model to capture complex data. Batch normalization is a technique that makes our deep learning model learn faster and more efficiently. Think of it like a quality control step inside the model. It ensures that the data going into each layer is consistent and well behaved, preventing the model from getting confused and allowing it to train much more quickly and stably.
Next is the upsampling layer. Upsampling is the process of taking a smaller low-resolution image and making it bigger and more detailed. In our model, after we have used layers to find the tumor's key features, we use upsampling to bring the image back to its original size, ensuring the final tumor outline is sharp and accurate. Finally, our model used a pixel classification layer. This is a very last step. This layer looks at each individual pixel in the image and decides if it belongs to the tumor or to the surrounding brain tissue. This is how the model creates the final details outline of the tumor. And our big challenge we faced was class imbalance. This happens when one part of the data is much smaller than the other. In our case, there are small pieces of tumor which is much smaller than the main one.
And so that to address the challenges of class imbalance, we utilize the generalized die loss instead of standard cross-entropy loss, enabling our model to better learn from the underrepresented regions. So basically, generalized die loss increases the weight of the small tumor, so the model care more about it. And for training process, we use 5 patient data for training and another 5 for testing. The data was selected from the 2020 dataset, and the Adam optimizer was selected due to adaptive nature and effectiveness in deep learning context. We initialize the learning rate at 0.0005 and apply a special reaction for every 5 epochs to promote a stable convergence. And validation was conducted in every 4 iterations to continuously monitor the model performance. The network was trained using the specified loss function and training option.
And our model has 3 key functions. The first is block-wide segmentation. Since MRI images are very large, we break them into smaller blocks. Our model processes each block separately, which makes it much faster and use less computing power. Second, it has a visualization function. We can take the model's prediction and place it right on the top of the original MRI image. This creates a 3D view, allowing doctors to clearly observe the affected regions. The third function is the most important, volume computation. Our model calculates the exact volume of the tumor, both from the original image and from its own prediction. This can even show the percentage of overlap between the two. which is called similarity score. This tells us exactly how accurate our model is. And to make sure these calculations are perfectly accurate, we use information from MRI file itself. Things like the pixel spacing, slide thickness, and space between the slices tell us the real-world dimensions of the image. This allows our model to give a precise real-world volume measurements of the tumor.
Let's see our result. So figure 1 shows a side-by-side comparison between the ground truth on the left and the predict on the right. As you can see, the predict has closely aligned with the ground truth. Now, to better illustrate the spatial accuracies, we use 3D rendering to the virtual functions. So the left one is the ground truth and the right one is the predict one, enabling the better visual verification and comparison. Our model achieved a score of 0.9625, about 96%, which indicates a very high overlap. We also measure the volume. The ground truth was 107,328 cubic millimeters, while the predict one was 107,329 cubic millimeters, and had an overlap up to volume of 103,302 voxels. Let's see our conclusion and discussion. So, in summary, 3D unit has successfully segmented a brain tumor from MRI image with a very high accuracy, so approximately 0.96, and automated segmentation has provided 7 times speed advantage than the manual and the semi-manual 10 to 20 times faster due to GPU performance. Accurate tumor volume estimation plays a crucial role in supporting clinical decision making, and under-segmentation of a small tumor due to class imbalance and variability in MRI quality affect the segmentation performance. Thank you for your listening. If you have any question, please feel free to ask.
Now, we would like to proceed with question and recommendation. Please invite and ask some questions.
What was that? I couldn't hear the last part.
We would like to invite Dr. Thawat Chittakan to ask questions and give some advice.
Yes, your work is very interesting. What is the MRI stand for?
Magnetic resonance imaging.
Yes, I understand that your model is tied to locate the and size of the tumor, right? And
Yes.
if the case is when the tumor is very small or tiny, the AI can miss it. And how you can solve this problem?
So I would say we use generalized dye loss. So basically, normal model use the dye similarity loss, but we use generalized dye loss that increase the weight of the small tumor in the same slice. So it will care more about the small tumor.
I don't quite sure that they have a medical doctor in your team or not.
Yes, we have.
Oh, you have.
We have the
That's
doctor
why.
from PSU radiologist part.
Oh, okay. So they provide the image to this project, right?
No,
No.
for the data, we use the public data.
Or public
We use
data.
the BRAD 2020 dataset. It is like a standard dataset for doing things like this. It's probably from 2020. Yeah, it is a very clean dataset, and they have the DICOM metadata too. They already give us the DICOM metadata, and it don't have the patient name, so we don't have to wait long. Yeah.
How big of a data set? Because you can achieve high accuracy to 0.96 is quite high.
Actually, it have about 200 or so data set in the data set. I mean, 100 or 200 or so in the dataset file, but we choose only 5 cases for training because MI is quite a large file, and we achieve like already achieve a very high score. Yeah.
What is your future plan for this project? Is because it's very interesting.
So I think in the future, maybe we will move. So now we make this in MATLAB program, but we are planning to move it to Mathematica, which will make the image or the 3D model even more detailed. And I think we may have to train it more due to the problem that we face, which is it can detect the smaller part like this, which will make a lot of effect to the patient.
And we have a plan to not just use this AI in the brain only, so we might spread it to other organs in the body too. And our goal is to reach the accuracy of at least 0.97, because in medical term, if our model will use without doctor, it has to at least about 0.97, but our only got about 0.96, so we have trained a lot more, and we train other organs in the bodies too.
Okay, thank you. I would like to convey microphone to Dr. Tibenis.
Okay, thank you. I think your I loved it a lot. I think it was near perfect presentation. In fact, let me give you my special bell for a good job well done.
Thank you so much.
Yay! Oh my God.
I actually have it from my classroom. So I like your intro story, how you lead into the actual project, and also the goal. The goal of your research is not to classify images, but just to get the volume of the tumor. That's the basic information. You go on to the very core, and it can also be verified easily from the ground truth, right? So I said it was near perfect, but not perfect. I didn't like your report. It was too short.
Okay.
And also, let me check. You seem to have a good knowledge of how AI works, how you change the loss function, and so you account for a small tissue. So let me check a few more. So here's my quiz. Explain what ReLU activation function is.
ReLU activation function.
Oh, really? Yeah, really. Okay.
So you want to know, so ReLU is like it made our model learn faster. So if you see that if you have the graph like this, the parabola graph, you think that the least part is the goal that is 100% accuracy, and the top up is about 0 accuracy like that. And our train is like pointing a line into the curve of the graph. If the line go near the least part of the graph, so it reach the high accuracy like that. And but when you point a line, at first it does not go straight to the bottom part. You go to the edge and bounce like this, bounce up and down, right and left like that. So basically, ReLU activation function is like a roof. It make the line not go up. So if you just it force the accuracy to go higher only. So when we train, the accuracy will not become lower. It's like as I say, ReLU is very simple. If the value is positive, we keep the value, and if the value is negative, we set it to 0. You get that? So
If you not like, what could you use your finger to draw me a graph of the RELU
can
activation
I use
graph?
Can I use my iPad to show you?
Sure.
Wait a minute.
So it's flat zero if the signal is negative. Am I correct?
If the accuracy become lower, so it will not keep like this.
Okay.
Please.
Negative signal is flat zero. If the signal is positive, what happens to the activation graph? Good. Now show me the graph.
If this is the accuracy graph, and at the bottom point here is the 100% accuracy,
Okay.
and about zero. So when we start training, we will shoot the laser at the graph, and this laser might come down like this or come up like this. Get it? So right here is about 20% accuracy. So if the line bounce up like that, we will take a lot more time to train right because it trained in the wrong ways. We want the line to only go down to nearly 100% only. You get that?
Okay, I got that.
So ReLU attrition function act like this. If the line come to here already, it will make a roof here. So our line cannot bounce up. It only bounce down only. You get that? So if our
Okay.
line shoot here already, it will make a roof here. So our axis don't go up. It only go near 100% only. You get
Okay.
that?
So I think you understand what the RELU is. Now my last quiz question. What is Atom Optimizer?
Adam optimizer is like a optimizer for 3D imaging. We don't know much because we have the advertiser too. We have studied from literature review and we have the advertiser that say that this optimizer was good for 3D imaging. So we don't. Adam optimizers. Yeah, right.
Yes, that's the one. There are so many optimizer. You have Atom, you have gradient descent, you have Atom stochastic. So I would urge you to look more into various optimizer modules from I think it was Keras or TensorFlow, perhaps. What is the platform for this project?
Can I have the question again, please?
What Python module did you use for the project? Was it Keras or TensorFlow or Google Collaboration?
Oh, this was MATLAB.
Oh, okay. Fine. So you can look at the Atom optimizer and what it does. Maybe pick another one that is more suitable for the tumor image processing.
Do you
Okay.
have any suggestion for the optimizer?
For our future.
I don't have any. I don't know much about the various optimizer, but then again, it's not my job. It's your job.
Thank you.
Okay, all right. We'll upgrade that in the future.
Okay, thank you.
Thank you so much.
Thank you for your question and advice. Now let's move on to team ISP24.
The evaluation of carbon dot benefits for cancer treatment.
I think it comes to 16 billion. This is-
You may start your presentation whenever you're ready.
Right, I'll just do a few final preparations. Thank you.
Before you begin, could you give us a big smile because you seem tense now?
Yep, just a few difficulties. I'll get right to you. All right, I will start sharing my screen. Please hang on 1 second. All right, just to confirm, is my audio coming through clearly?
Yes, I confirm, but I haven't seen the smile.
Oh, okay. There you go. All right. Great. Thank you for confirming. Let's get started with the presentation then. So, hello, honorable judges. My name is Natwakrit Petwini from Trim Unom Siksa School, and I'll be presenting my research topic on the evaluation of carbon dot benefits for cancer treatment. First, let's start with the topic background. Cancer is one of the most severe medical conditions that healthcare has to face, and it is the second leading cause of death, claiming the lives of 1 in 6 people, and that number is only expected to rise. Hence, that is why solving cancer's impact is one of healthcare's main goals, with the 2 main approaches to complete this daunting task being, number 1, achieving early detection, which makes patients 65% more likely to survive, and number 2, increasing treatment efficiency. Both of these approaches can be acquired through the use of compatible biosensor, in which carbon dots make a prime candidate. But first, what are carbon dots? Well, they are structures formed by nanoscale carbon particles, arranged in various structures and often paired with surface functional groups. These nanocompounds are known for their chemiluminescence, a fitting biosensor for clearly indicating biomarkers. To add to its biosensor properties, carbon dots are also highly safe and biocompatible, while being easily functionalized, cost-effective, and eco-friendly. The mentioned credentials of carbon dots can be utilized to alleviate cancer's issues, all through its fluorescence when bound with cancerous compounds, receptors, or cells, in which its emitted spectrum can be evaluated, indicating specific cancer types and stages. Moreover, these functions are widely compatible and adaptive, ranging from testing cancer alongside blood tests in field health checkups up until highly precise imagery evaluation in full-scale labs. All of these carbon dots' intriguing benefits have inspired me to create this research project, to evaluate the benefits of carbon dots in the 2 main cancer-solving objectives. Number 1 being achieving early detection, and number 2 being achieving treatment efficiency. To be more precise, the literature review aims at these 2 objectives. In order to evaluate the benefits of carbon dot-based biosensors in number 1, cancer biomarker detection through blood samples, and number 2, targeted tumor imaging. With these goals clearly set, I set off to source trustable research articles about carbon dots and its use through the use of keywords. Next, the acquired literatures are analyzed through evaluation criteria and categorized into two main types by application. Category 1 is reviewed to identify the benefits of carbon dots in blood sample biomarker detection, and Category 2 is reviewed to identify the benefits of carbon dots in targeted tumor imaging. After thorough review and analysis of each article, outcomes of carbon dot benefits in both categories are acquired, with biomarker detection results aimed towards cancer cases and implementation, while tumor imaging results are aimed towards imagery cases and safe usage. Let's start with our first objective of blood sample cancer biomarker detection. Results show that carbon dots are able to react with different biomarkers in blood samples, illuminating with unique wavelengths which clearly distinguish different types and severity of cancer. This is achieved through the configuration of carbon dots to target different molecules. The specific details of the detection of three prevalent types of cancer are as follows. In blood samples, testing for lung cancer employs antibody-conjugated carbon dots, which are able to capture up to 100% of lung cancer exosomes, followed by the release of distinct spectrums to indicate metastasis and resistant status. My apologies. Meanwhile, testing in pleural fluids are also possible through DNA duplex releasing carbon dots, which indicate the presence of carcinoembryonic antigens from a wide linear response range and a low limit of detection. This application shows the high performance capability of carbon dots in capturing and expressing biomarkers. In the case of breast cancer, nitrogen-doped carbon dots proved to be successful in binding to cancerous proteins, again showing a wide linear response range and maintaining a low limit of detection. Furthermore, carbon dot applications express high specificity to biomarker types, stability when bound, and reproducibility across different cases, while it also delivers accurate measurements in efficient and practical screening. In the third cancer case studied, biofunctionalized carbon dots are able to detect colorectal cancer through carcinoembryonic antigen biomarkers, with results retaining its characteristically wide linear response range, while also offering a low limit of detection. This is along with extra benefits of higher sensitivity and precision. From all three cancer cases analyzed, an overall comparison accentuates carbon dot benefits over traditional methods of cancer detection. In this case, results are compared to enzyme link immunosorbent assays, with carbon dot-based biosensor assays presenting up to 1,000 times lower limit of detection, which facilitates earlier detection. This also reflects to lower starting points for the linear response range, which corresponds to the lower limit of detection. The range itself is comparable to the conventional assay, but accurate results and reliable readings can be acquired all throughout carbon dot's detection range. From all the benefits mentioned, carbon dots can be implemented as paper-based electrode strips in portable test kits, which ignites a new horizon for cancer testing, one that is more accessible, convenient, rapid, resourceful, and more effective. All in all, carbon dots as a biosensor delivers more efficient and quality screening for a new level of early preventive measures, ensuring more recovery chances down the line for cancer patients. Next up, the second objective of targeted tumor imaging shows a result just as intriguing. In this case, carbon dots are targeted towards reacting to biomarkers in cancer sites, which are followed by accumulation of these fluorescent particles, in turn indicating tumor areas under various types of imagery as follows. In the first type studied, which is magnetic resonance imaging or MRI, results show that GD-doped carbon dots present 6.5 times higher longitudinal relaxivity, along with more magnetic moments and blood retention time, all of which result in brighter signals and clearer tumor images. The next type of imaging analyzed is computed tomography or CT scans, which prove to have higher CT attenuation and higher tumor area contrast, all of which contribute to higher definition readings. And the final case presented here is near-infrared fluorescence imaging, in which membrane-coated carbon dots exhibit higher tumor-to-background ratios, a crucial point to indicate cancer sites' visibility. After detailed analysis, results from all three imaging cases are compared, which shows that carbon dots benefit visualization with higher contrast, better tumor-to-background ratios for overall brighter, sharper imaging of tumor areas under various types of imaging. All of these upsides mean carbon dot-based imaging agents can track tumor areas which do not appear traditionally, resulting in a complete diagnosis and streamlined recovery plans for a more specific cancer treatment and better patient well-being. Apologies. Apart from performance, carbon dot imaging agents are tremendously safe. The absence of heavy metals result in 95% higher cell viability, even in high concentrations and prolonged usage, while clearance times are remarkably quick, with all agents excreted within 24 hours. All of carbon dot's benefits in the results align with published research in both areas of 1. Blood sample biomarker detection, and 2. Targeted tumor imaging, which shows more sensitive and convenient detection for the first topic, along with sharper images and less toxicity for the second. In conclusion, carbon dots offer properties of being configurable and luminescent. Both of these properties can be utilized in the form of test kits to evaluate cancer presence through patients' blood samples, with results being earlier, more cost-effective, and more reliable than traditional tests. Carbon dots are also capable of displaying areas with cancer cells through imaging of accumulated particles alongside improved clarity. Reduced toxicity. Both implementations are a driving factor in the next level of cancer treatment, achieved by early detection, streamlined monitoring, and increased treatment effectiveness. Apart from that, these are further suggestions for the project, which can be implemented in further testing in vitro and in vivo, and comparing results to traditional methods in all processes from manufacturing all the way to patient results. While further development can also be organized with AI integration, automated cancer diagnosis, in clinical trials, and approval to ensure safety of carbon dot application in cancer treatments. And from this, I would like to thank you all judges for viewing my presentation, and thank you for listening to this presentation. Thank you so much.
That was an incredible presentation. And next, we would like to proceed with questions and recommendations from one of the judges. May I invite the Associated Dr. Tiffany Castillo to ask the questions and give advices.
Okay, I would try to be as constructive as possible. First of all, the sound's great. I was in a movie theater or something.
Wow.
But when I was looking at your report and the project, and I saw potential that you are interested in this topic of research and the carbon dot thing, but I haven't seen the action besides the review of literature. So let me ask you briefly, what was that you do or did to contribute to the understanding of carbon dot?
Thank you for the question. To answer this, I would like to answer that in this research project, I have compiled the benefits of carbon dots in the two main areas that would benefit cancer treatment, and to show that carbon dots have a high potential, and to give a compiled resource for those who would like to implement carbon dots into cancer treatment, for those who have the resources to manufacture carbon dots and to do actual testing. And I'd like to be part of that force. And I believe this information supports the researchers in that area and would give them a better overall understanding of carbon dots in the field of cancer treatment.
Okay, so I'm not gonna try to trivialize what you did. Actually, compiling what we know about cancer and carbon dot actually is valuable work. We have this what we call a review paper on certain topics, and I think that's what you did, compiling all of the important information. But when you focus on the research project in the high school level, doing something on your own is actually also important, besides studying what is known already. So I would ask you a hypothetical question. If you were to try to plan a small experiment or something that you would do on your own on this topic, what would that topic be?
I would like to break this question into two answers. For the first part, I believe the part that I did on my own, like what I've created in this project, is that I have compared the performance of carbon dots with usual types of, for example, cancer testing and imaging, which I believe isn't done in other research projects. They just test performance of carbon dots, but I have compared with traditional methods to show its performance and its viability. That's for the first part. And for the second part, I would like to answer that if I were going to keep this research project going, I would love to actually manufacture carbon dots to test its viability, both in cost effectiveness and resources. And from that, I would also like to test those carbon dots that I've manufactured to prove that it's safe, it's reliable, could possibly be in just cell tests or in test subject animals. But that is the next level that I would like to extend this research project into actual production and testing. That would be my goal.
Okay, I think that would be interesting for you to actually test it yourself, going into the lab and have some joy of breaking glasses or something like that. So let me move on to the next topic. You said that the carbon dot was safe, but it didn't sound safe to me. It sounded like something foreign that I would need to drink it into my body. So could you give me a sort of evidence that this thing, carbon dot, is safe?
All right, so I would like to answer this question in the according to the two objectives of my project. So first of all, it's safety in blood tests So in this part, no carbon dots have to actually be injected into your body. It's just like a usual blood test. They extract your blood and they put carbon dot particles in and then analyze the fluorescence it gives out. So carbon dots has no relation to our bodily functions here. But in the second part of targeted tumor imaging, I understand that this one has to be intravenously injected and it may cause some concerns, but carbon dots at an elementary level are just carbon atoms doped with different chemicals, which are already used in many types of imaging. So, and moreover, carbon dots are not composed of heavy metals, and they are basically a neutral compound that is made out of, well, natural ingredients. And so when it's injected into our body, it will just circulate like any other chemical. And research has shown that it is safer for longer usage and more concentrated usage in tumor imaging. While it also excretes faster, it gets out of your body quicker compared to other types of imaging. And it is shown that carbon dots, when used as these imaging agents, do not create any type of inflammation or infection or blemishes to your body when compared to other imaging agents, which is quite an important point in, well, MRI, CT scans that could take a long time, and I believe is the new level of safety for these types of imaging.
Okay, I raised my case. Again, I think you have a perfect skill of articulation. And if you try to walk into the lab, that it'll be a lot more fun. Okay, thank you.
Thank you.
For me, you mentioned AI can incorporate in the quantum carbon dot technique. Which part of the process that you plan to use AI to cooperate with?
Thank you for the question. In this part that AI integration, I believe it could be used in the result analysis of carbon dots. You see, when carbon dots are put into blood samples or are injected for imaging, the results might not be very visible for human analysis. For example, when an imaging results come out, there might be some very faint traces of carbon dots in some areas which humans might overlook. But if it's AI, they could track these areas that could be overlooked and present these to medical professionals, giving them a more complete analysis that they might overlook some cancer areas, which result in better treatment, more specific, and fixing the problem all at once. Like AI basically cooperates with medical professionals in analyzing results presented by carbon dots, basically boosting result analysis.
Can you give the key difference between the carbon dot and the quantum dot?
Carbon dots and quantum dots are quite similar, but from what I've researched, carbon dots have an added element of configurability. It can be doped, it can be added to different types of compounds in order to tailor its usage to different applications, which is important in cancer treatment since there are many types of cancer, and to be specific is really important, which is the main trait of carbon dots.
Okay. And what is your future plan?
My future plan?
You going to be a medical doctor in the future?
In my future plan, I would like to be a pharmacist, which I think really takes this into occupation levels, since I would like to develop, for example, blood testing agents for cancer, or it could also be contrasting agents for magnetic resonance imaging or stuff like that. I would like to develop these chemicals, these products from carbon dot that can further benefit cancer treatment and healthcare.
Okay, so good luck for your future.
Thank you.
Okay, thank you.
Thank you. Now let's move on to team ISP19.
Smart home security system. They are from SMK Methodist, Malaysia.
Okay, you can start now.
You may start whenever you're ready.
So good morning, everyone. I hope you.
What else do you have as a detector?
We also have ultrasonic, which can detect the distance, like the door is opening and the distance of the door opening, and it's also a motion sensor.
Again, please, I didn't get this one. What did you say?
Okay, so actually this is ultrasonic sensor. So when they open the door, like a thief entering the door, and like when he opens the door, this thing will automatically keep the distance with this, which is they are here or not, something like that.
Okay.
Just about the distance. And
A
it
distance
will trigger
sensor.
it will trigger to the IR sensor here.
And we also have the camera. This is called as ESP32 cam, which
Okay.
has its own flash. So if it detects, the IR sensor will send and trigger to ESP32, which is the brain. And the brain will ask the camera to take a picture of that. And it has its own flash. So even at the night, it flash and take a picture and send to the telegram.
Okay. So the ESP32 is the brain of
Yeah.
these detectors.
It's like a microcontroller.
Okay.
And the Wi-Fi will be normally in the house Wi-Fi or in the office, in the school. Will be connected to that. The ESP32 will be connected to that.
How expensive is the whole thing? Include all the detectors and the controller, the wiring, and so
We
forth.
bought it all around 150, less than 200.
200. Are we talking about
Malaysian-
dollars, US dollars? Or
Malaysian
what?
ringgit.
Malaysian
Cur-
ringgit.
Malaysian
Let's see,
ringgit.
how do I compare that
Basically,
to?
Oh, so if we convert it to Thailand baht, it is 979 baht.
Oh, that's not expensive.
Yeah,
Less than 1,000 baht. Okay, very good.
cheaper than other products.
Okay. So is this project finished? Because I've seen that the wiring is very short.
It's still under construction. It's like
Okay.
a prototype for now, yeah.
Okay. Let's see. I have a list of my questions here on my notes. Well, no. I still think I want to see the picture of your schools or your city where you live. That'd be very exciting to me to see the actual place.
There's a media.
But if you don't have, it's okay.
We can
What?
search it.
Oh, what about the phone? You said you would control these devices using your phone.
Yes.
Do you have the image of the phone
I just
that you're using?
show on me.
Oh, this is the one. This is your app.
Let me edit. Yeah, sure. No. Okay.
This will be
So
like,
explain your app again.
it's a Telegram, which is a social media used by every country and everyone can use it. And it can be downloaded in iOS, Android,
Okay.
and
So
Windows.
your device send a message and here, and then what's the name of the app?
Telegram.
Ah, okay. All right. I think I don't have any more questions. I wish you well on your journey to become the inventor in, what was that, Malaysia?
Yep.
Yes.
Okay, good job.
Thank you.
Thank you very much for your questions and valuable suggestions. And now on to the last team. In 2 minutes, we shall start at about 11:30. So we will have a 7-minute break. ISP 06, are you ready to present now?
Yes.
Okay, then last but certainly not least, ISP 06, developing a web application to classify risk levels of breast cancer from mammogram imaging.
They're representing by PSQ Veterinary School, and the researchers are
Sorry.
Okay,
Wait a minute, please. I can't open up my video.
Right. Well, whenever you're ready.
Okay.
Basic.
Wait a minute.
Your presentation is okay?
หนูเปิดกล้องไม่ได้ค่ะ
อ๋อ หนูเปิดกล้องไม่ได้
ใช่ค่ะ
อ่าฮะ
ไม่ต้องปิดกล้องนี้อยู่ปะปิดกล้อง
เห็นใช่ไหม
ให้เวลาลองดู
ไอ้
เอาแล้วได้แล้ว
โอ
ค่ะ
เค ได้แล้วครับลูก โอเคครับ กรรมการครับ โอเคได้
หนึ่ง
Okay, you can present.
In time. In the Good morning, everyone. We're a student from PSU Veterinary School. My name is Tanisha Khamir. And my name is Teresa Miller. Today we will present our project, developing a web application to classify risk levels of breast cancer in from mammogram. Currently, the numbers of breast cancer patients has been increasing every year, both in Thailand and around the world. According to Global Chem 2020, breast cancer is the most common cancer found in Thai women, and data from Songkhla Nakharin Hospital also show that breast cancer is the number one cancer found in women found in patients of all genders. To disappears that hand belong of women in their family. Breasts are not only important to reproduction and feeding baby, but it also represent femininity and beauty. That's why getting breast cancer can affect both their body and their mind in deep way. So in the screening process, mammography is the most effective first-line method before biopsies. However, there are about 17 million women per year who need mammogram screening, but only about 1,815 expert radio tests are available. This gap causes delay, limited access, and miss for early detection and treatment in time. So, wouldn't it be better if we had AI that help pre-screening mammogram quickly and high accurately? Because of this, our project aims to develop a mathematical model that can
mathematical model that can take rate levels of breast cancer using mammogram image that could reduce workload from radiologists and help more people get diagnosed and treated in time, especially in hospital with limited resource, because early detection leads to faster treatment and more chance to recovery. Our system will using BIRAT system. BIRAT can be divided in 7 levels used of risk level. BIRAT 0, 1, 2, 3, 4, 5, and 6. That you can see the difference between each BIRAT are very visible. That's why it requires high skill of the radiologists to identify them. To address this challenge, our project aims to following the objective to develop a mathematical model that can estimate risk levels of breast cancer and use this model in web application for easy to use and improve efficiency in medical care.
In methodology, we have 2 main steps: process of training a model and process of displaying a model as web application. First, process of training a model is divided into 8 main steps. First of all, dataset collection. We use online dataset divided into 5 classes, which has the data imbalance issue across classes. Secondly, data pre-processing. We convert all mammogram images into grayscale format. Then the feature engineering. First, feature extraction. Features were extracted from mammogram images using local binary pattern or LBP. The output was histogram showing the cumulative frequency of pattern found in each mammogram images. After that, to address the class imbalance issue, we conduct class balancing using 3 approaches. The original dataset, we use stratified split to the dataset, and in 2 more approaches, we use oversampling, that is image augmentation. We consider image by oversampling the minority class using techniques such as horizontal flip, zoom out, rotation, and enhancement. And then smooth. Smooth was considered features by generate new data points in minority class between the existing features. Next, the model training. We trained the model using k-fold cross-validation, and the data was split into train and test sets using stratified split. We trained 15 classifiers using PyCaret library to identify the best performing classifiers. The model evaluation. We evaluate the model using accuracy to determine the best one. And then finally, we save the best model with the highest accuracy from 30 experiments was saved, and then we use this with application development. So let me explain this chart. First of all, in class balancing, we use 3 methods: original dataset, image augmentation, and smooth. And then in model training, we use 2 strategies of k-fold cross-validation. K equal to 5 means train to test equal to 80 to 20 ratio, and K equal to 10 means train to test equal to 90 to 10 ratio. And last one, feature extraction. LBP features will extract with 5 different radius parameters are equal to 1, 2, 3, 4, and 5. From 15 classifiers, the best of best results were selected, considering all parameters combination. A total 30 experiments were conducted. And then the process of displaying the model as web application. In this step, we use the model to create the web application with Gradio library by perform the pre-processing and LBP extraction step as same as we use in the training process. And the result from our experiments, original dataset perform accuracy range from 0.82 to 0.85, and image augmentation perform the accuracy between 0.69 to 0.75, and smooth perform the highest accuracy range from all three approaches between 0.94 to 0.96, which the highest is 0.9625 using k equal to 10 and r equal to 1. Although the smooth results were generally close, so we choose the model with the lowest r or r equal to 1 due to the fewer features resulting in less complex and faster models. And this the result visualization. The web application successfully predicts mammogram images accurately based on the trend model. This is because the web application go through the same pre-processing and feature extraction step used in the training process, and using the same parameters will give the same answer, ensuring that this web application can predict and display results with the same accuracy as the trend model. And this demonstration of how to use the web application. First step, we upload the mammogram images into the web application, which then process them and present the prediction based on the virus system, along with additional suggestions. So you can scan the QR code to experience the web application. In conclusion, for multiple experiment, the base performing model using LBP with R equals 1. K-post correlation for data augmentation and XRT classifier. This combination achieves high accuracy and is accurate enough for use in the real world, predicting breast cancer level in medical setting. In the future, we plan to first is to select more data sets. After that, we will create a simple model that's easier to use. We aim to develop an application that can use in real hospital to support doctors in their work. Thank you for your attention.
That was a really great presentation. Now we would like to proceed with questions and recommendations.
I invite Associate Professor Dr. T. Panitashio to
Sorry, one more time, please. I can't hear. I can hear his clearly.
May we invite Associate Professor Dr. T. Panitashio to ask questions and give suggestions. I believe your mic is turned
I'm
off.
sorry, my mic was turned off. Could you show me again slide number 5, please? It was about the objective.
5.
No. Okay. Here you said that you wanted to develop a mathematical model, but my impression is that you are building an AI machine. So I guess my question is, what kind of mathematical model did you get out of the research or the study? What equations? What formula? That's what you said. You want to get the mathematical model. So what model did you get?
We use XRT classifiers in the results.
But that is just a keyword, though. It does not tell me anything about what equations they were or what sort of theories that you got.
Oh, yes, LVP. This model we use, this model can be divided into parts. In the first part is, in the past, it have formula is the feature extraction. So how to calculate the model using like LVP to calculate. This LVP using is we select the center pixel, and then we select the center pixel, then we compare the values with the
around this pixel. That's for example, like if we select the black one is the centers, and we will compare with the value with the around. If the value if this is this pixel more than the center pixel, more than the center pixel, we will repeat with 1, and if it's less than, we will repeat with 0. So we will create in chemical value and decimal number and repeat the value we in the result pixel. Yes, in each pixel, and we will do it for all pixel. This is the value is called like feature, and we will collect the feature as a histogram, RBP histogram, when we use this histogram to train model.
So again, I don't want to use too much of a technical jargon, but this convolution matrix is what you invented, or you just use what is available already. The LBP.
Already has. It's already
Okay.
has. It's just like technique.
Okay. Okay. I got it. My next question is that you were talking about issues that you were balancing, or what was the problem in the first place?
No. Long zoom factor. Class balancing.
Because like the data set we use is online data set, so we in
Is
the
what
each
I didn't
class
get that last sentence.
in each class there has the image that not equal, so we use image augmentation to increase the image in minority class.
Oh, I see. So
So
some images are small, some are big. They're not of
yes,
equal
yes.
size. Okay. So you have to sort of augment the images to make them of the same size before processing. Okay. Go on. So what is class balancing?
We try hash balancing two approaches, but we use mode that is create less.
The problem of class balancing is the amount of picture is in each class is not fair for training. So the method is we use Samod. Samod is like we plot the graph and you can see this is
Majority.
is like majority class, and this is minority class. We need to include minority class, then we find the
we create a new features point, which is the rate one between the existing features, which we use more because it's create a less oversampling. Yes, so we use more because it gives the higher accuracy.
It is not some also mode we use like all data augmentation, but it's overfitting. That means the AI is not smart enough for use. Then some mode is good for use from the experimental.
So SMOTE is a good option, but what does it stand for? What does it do? What is the concept behind the algorithm of
The
SMOTE?
concept of the algorithm is this is will
First,
create
what does it stand for? What is the full name of SMOTE?
some more
It's synthetic minority oversampling technique.
And what does it do?
It's create new data points from the existing data point. So the data will not like มันกระจุกตัว it's not like over something over something. So the data is like in the same area as the existing data point. That create the high accuracy.
Okay, I think I got it from the picture. What I'm seeing is that on the left image you have the blue and the green, right?
Yes.
But the green has some missing area where there's no data. And so therefore we use smoke to fill in the details, and that's where the red comes in. The red is the imagining data that added to the pool of data, and that is the additional data from the smoke. And therefore, at the end, on the right image, you have sort of a spread, a widely spread and evenly spread of the data across the data set. Am I on the right track of understanding this mode?
Yes.
Okay. Good. That's all the problem I'm sorry, question I have so far.
Thank you.
We invite Associate Professor Dr. Thawat Chitrakan to give suggestion and ask questions.
I understand that your advisor came from the medical faculty,
Yes.
right?
Yes.
So what is your future plan after this?
One of our future improvement is to request approval from ethics committees. This will allow us to access the larger and more diverse medical data sets while ensuring that the patient's fundamental rights are not violated, since the EC consideration are highly important in medical field.
Oh, this is a real research project, right?
Yes.
Okay, that's all. Thank you.
Thank you.
All right, everybody, that is the last group for this morning. So we are going to have a break until 12:55, and then we will continue our presentation at 1 p.m. So have a great lunch, everybody, and see you then.
Thank you.
คุณท่านคณะกรรมการสำหรับช่วงเช้านะครับเดี๋ยวเริ่มทีเที่ยงบ่ายโมงตรงทีนี้เดี๋ยวเรียนแจ้งท่านคณะกรรมการว่าเดี๋ยวสามารถที่ช่วงเช้าสามารถก็เดี๋ยวช่วงบ่ายอาจารย์ทีบอกว่าถ้าเป็นไปได้อยากได้แบบเดียวเพราะว่าเดี๋ยวตอนท้ายครับจะมีเวลาประมาณ10 นาทีผมให้คณะกรรมการได้ทยอยส่งผ่านตัวกรองเพราะปีนี้จะใช้การประมวลผลแล้วก็ประกาศช่วงท้ายเลยครับ
อธิบายใหม่ได้ไหมครับผมฟังไม่ทันประโยคแรก2 ประโยคแรก
ก็คือว่าเดี๋ยวช่วงคะแนนในช่วงเช้าถ้าอาจารย์สามารถเคลียร์ส่งได้เลยแล้วก็ทีนี้พอช่วงบ่ายทีมบอกว่าอยากจะได้แบบคะแนนแบบเดียวแต่ถ้าอาจารย์ไม่เดี๋ยวช่วงบ่ายเพราะว่าเดี๋ยวทีนี้เราจะใช้วิธีการก็คือ
เสียงในห้องประชุมเนี่ยไม่ดีเลยนะ
อ๋ออันนี้ได้ยินไหมครับอาจารย์
อย่างนี้ได้ยินเนี่ยตอนพวกพรีเซนต์ในห้องเนี่ยขอให้ใกล้ไมค์หน่อยเพราะว่าเสียงมันขาดหายแล้วเราจะจับประเด็นได้ยาก
ได้ครับก็คือเดี๋ยวเบื้องต้นก็คือเดี๋ยวคะแนนอาจารย์สามารถเคลียร์ส่งได้เลยครับอาจารย์แล้วก็เดี๋ยวตอนบ่ายที่บอกว่าอนุญาตว่าไม่ได้ ทีละกลุ่มทีละกลุ่มสามารถส่งได้เลยก็คือได้เลยถ้าเกิดว่าอาจารย์ไม่ทันก็เดี๋ยวน่าจะมีแคสตอนกลุ่มสุดท้ายประมาณสัก10 นาทีผมให้อาจารย์ได้รวมแล้วก็ส่งมาในGoogle Form ก็
ได้ครั
ห
บ
ลังจากนี้วันนี้ก็คือจะประมวลแล้วก็ประกาศช่วงท้ายเลยครับ อาจารย์ในห้องรวมซูมเหมือนเดิมครับขอบคุณมากๆนะครับอาจารย์ค
ครับผม
รับ
สวัสดีครับเดี๋ยวเจอ
ส
กัน
วั
ให
ส
ม่
ดี
ครั
ค
บ
รับครับ All right, it's now now that it's now almost 1 a.m. 1 p.m. Sorry, and I'm sure we have all had our lunch. So now let's start with the first team after lunch, ISP02, Biofabric Heal Wound Healing Patch from Ultrasound Assisted.
They are represented by Demonstration School of Prince of Songkhla University, Secondary Thailand. The researchers are Ms. Avani Mayu and Ms.
All right, you may start whenever you are ready.
Okay. Can you guys see the screen that I'm sharing right now?
Not yet.
Yes.
Yes.
Okay. Can you guys see it?
Okay.
Yes.
Yep.
Should we start right now?
Yes, if you are ready.
Okay. We're gonna start in 3, 2, 1. So hi. Imagine living with a wound that just won't heal, the wound that keeps you from daily life and in some case could even lead to a losing a limb. Hi guys, today we represent you guys a Biofabric Heal wound healing patch from Ultrasonic Assistance. So we are Sophia Busa and here is and Amani Mayu. Yeah, so we from Demonstration School of Prince of Songkhla University. Let me introduce you guys. As I said before, this is the reality for diabetic patients, not just worldwide, but also here in Thailand, where the number of diabetic cases have raised. One of the most serious challenges for this patient is delayed wound healing process caused by the blue blood coagulation and nerve damage, which will increase the risk of infection. Recent breakthrough in the medicine suggestion natural solution. We interesting in Sensilla acetica, a medical plant which is known for centuries for its healing properties. It's a medical plant and it can use that have phenolic compounds which help regenerate tissue and also reduce inflammation, also fight for infection. Imagine if we could combine the traditional wisdom with the modern technology, and then we can create the wound dressing that actively heal the wound process faster and safer.
It'll be perfect if you slow down a little bit. It is
Okay.
almost perfect now, but it's a little bit slow down.
Oh,
It will be
yeah,
perfect.
sorry. And then, yeah, in our project, we use ultrasound assisted extraction. It is a cutting-edge technology that gives an efficiency extraction with the combine of bioactive compounds without losing their property. And also, this extraction then used to coat the medical gauze, transforming a sample dressing into a protective, antimicrobial, and also have antioxidants-rich barrier that can support faster recovery and minimize the scarring. Which make this project even more meaningful is that Sensilla acetica is locally grown in the Pattani province, yet still underutilized. By using the innovation extraction method, we not only improve the wound, but we also add value to local herbal resource and support rural community with the sustainable development. In short, our project shows the traditional medicine that can combine with the modern science and can work hand in hand to create the solution to heal the problem that we have in our society. And we believe that with the right plans, right concentration, it can give us the answer for this.
For the experimental procedure, powdered Centella acetica leaf will first be mixed with ethanol solvent to obtain a Centella acetica extract solution. The experiment will be divided into 2 sets A and B. The extraction of antioxidant compounds from Centella acetica to be used as a coating in experimental set B. The procedure was as follows. First, use 10 grams of Centella acetica powder were mixed with 80% solvent to total volume of 200 milliliters per experiment. The extraction was performed using an ultrasonic bath for 30 minutes. After completion, the mixture was filtered through thin cloth to separate the residue and collect the liquid extract obtained from the ultrasonic bath. The solvent was then removed from the extract using a rotary vacuum evaporator. After complete evaporation of the solvent, the obtained extract was stored at 4 Celsius and retired only when required for use. Next one, for set A, the Centella acetica extract solution will be mixed with ethanol at different concentration, which is 50%, 70%, 80%, and 100%. After mixing, wound dressing fabric will be immersed in the result solution and dried in an oven at 80 Celsius. For set B, the same procedure as set A will be followed with an additional step. After immersion and drying in the oven, the wound dressing fabrics will be coated with an antioxidant extract. After completing the experiment, the samples will be tested and evaluated using 3 methods. First one is choline-cytocolorimetric assay to determine the concentration of phenolic compounds in the extract solution, calculated using Beer's law. Second one is physical evaluation to observe the color of the wound dressing fabric and assess cracking or deterioration after immersion in a simulated solution. The last one is absorption test, consisting of 2 sub-methods. First one is absorption capacity measurement to determine the amount of liquid the wound dressing fabric can absorb. The last one is simulated soaking test, in which the wound dressing fabric is immersed in the simulated solution to study its absorption behavior.
Now let's move on to the data analysis. This slide presents the concentration of phenolic compound in the extract oven using different ethanol. We measure the absorbance 765 nanometer and calculate the average volume from this. We can compare how the solvent concentration affect the phenolic content. So this table shows that 100% ethanol gave the highest phenolic content, while 20% was the lowest. This proved that ethanol concentration directly affect the extraction of phenolic compound. Next, the results show that the wound dressing soaked in 70% ethanol had the highest absorption capacity in both sets. In set A, our maximum absorption is 14%, while in set B, the maximum absorption reached 80%. This indicates that 70% ethanol provided the best balance between compound extraction and fluid absorption. Next, in the stimulated soaking test, using saline solution, the dressing with 50% ethanol showed the highest absorption capacity, followed by 20%. The volume decreased with 80% and 100%. This means the lower ethanol concentration allowed the fabric to absorb more saline, which is beneficial for wound management. Next, finally, the coating efficiency result that 70% ethanol achieved the highest efficiency at about 163%, followed by 80%. Meanwhile, 50% and 100% ethanol show lower volume. This suggests that 20% ethanol is the more effective coating of active compound on the fabric.
So, ladies and gentlemen, so let me conclude you guys what our experiment is. So this study has highlighted the crucial role that solvent concentration play in developing efficiency of bioactive wound. And we found that the solvent in the range of 50 to 70% of ethanol allowed the dressing to absorb active compound and antioxidants most efficiently. These substances are essential in accelerate the wound healing process, especially for the patient with chronic conditions such as diabetes, where the developed healing is a major concern. Moreover, by coating the wound dressing with the antioxidants, we observe a significant improvement in their physical properties. The dressing becomes stronger, more flexible, and better at distributing the active compounds similarly. And this enhancement results brightness, improved adhesion, and also in the wound surface, and ultimately contribute the safer and more efficient way of healing process. What makes our approach particularly innovative is that when we use ultrasonic assisted extraction technology, this method is also increase the efficiency of extraction of bioactive compound from Sensella acetica. This medical plants is locally available and also well recognized by healing properties by combining advanced science and the traditional use in medical field. Thank you.
Next, we would like to proceed with questions and recommendations. May I invite Associate Professor Dr. Tuas?
Yeah, I have two questions. Why you choose to use Centra asiatica?
So the reason that we use this because actually our school is in Pattani province, right? And in Pattani province, the Sensella acetica is widely found anywhere. Like we just walk out in the day that we just thought like what the plant that we might use, and then like we saw this plant, and then we do the research about the what they have in that plants, and then we found that they have antioxidants, and then we just do more research about what antioxidants can be used for the problem that we found in our province, which is diabetes, and that the reason why we use that.
Are there any study that about the research and to confirm that the Centra asiatica have some kind of medicinal?
Yes. So they actually plenty of study of it, but we found the more interesting study is the study that when they are local in university, and then they study in Sensella acetica, and they do the measurement about what the type of antioxidant that they have, and then like we just found that they have more of antioxidants more than other plants in our province.
You mentioned that you use ultrasonic ultrasound assisted extraction is more effective than the more normal way.
Yes.
You have compared with the normal way, how many percent or the positive gain for this new technique?
Yes. So our study is we study the different type of the concentration in each ethanol, and then we found that when we use more of ultrasonic sounds, it can extract more antioxidants, and we found that the ethanol in the percentage of 50% to 70% have more efficiency more than other concentration that they can use with this mechanical.
Dr. Tipanet, would you like to comment on anything or ask?
Okay. Well, for me, it is a refreshing topic after I heard the AI the whole morning. So in the afternoon, now it's a good change. My first question is that I didn't quite get the name of the plant, the local plant. I guess you told me the scientific name. So
Yes.
what is the Thai name?
It's Baobab.
Oh, okay. You should have said that in the presentation. So I am familiar with this baobab plant. Good. Now, what I got from listening to your presentation is that you use the ultrasonic blast to somehow extract
Yes.
Extract what from the baobab?
Extract antioxidants from it.
Oh, okay. So my question is, would the ultrasonic destroy the antioxidant in that? In
Yeah, so we do some research of that, and then we also like asking the scientists, and then they said like it depends on how long that you use it. Some research say that it's about not more than 30 minutes should be used in ultrasonic assistant. If you use more than that, it can destroy the antioxidants. Yes, it can definitely destroy an antioxidant if you use in the wrong way.
Oh, okay. So you control the time, the exposure time to
Yes,
extract but not destroy. Am I
yes,
correct?
yes, the time and also
Okay, and
the
that
frequency of it.
oh, the frequency. Okay. When you're using this ultrasonic machine, can you hear it?
It's actually shaking, and it's actually shaking, and the sound is just a little sound.
Okay.
Yeah.
Now, I also have another questions. So once you get this antioxidant extracted, did you put that substance on a certain fabric that you made yourself, or you use a commercialized fabric?
We use it to put it on the gauze, like the gauze, the one that you put on the wound when you got the wound. Like
Okay,
it's a
so
medical.
it is a standard commercialized
Yes,
fabric that
yes,
you can buy it from a pharmacy. Okay.
yes, right.
Can you show me the picture of the final
Yeah.
product?
Yeah, sure. So here is the picture of our product. Like you can see it's dry because we put in the oven to make it more like of efficiency.
Okay.
Yeah.
Well, to me at least, it does not look clean to me.
Yeah. So
How do you clean it?
So our objective in our project now is to study about the physical of it. So we haven't studied about the how can you use on human because it have to be on the laboratory more, and then can have to taste on different bacterias. But now our scope is to study on the physical of how the different concentration can be used on the gauze.
So you're studying only the physical aspect
Yes.
of the fabric plus
Yes.
antioxidant. What aspect did you study again? Remind me.
Yeah, many of it. One is like how it affect in when we use to the simulate with the normal cell lines, or like how many efficiency of the antioxidant that they have after the different concentration, and also like how the cracking, is it cracking, is it too dry, is it too is it flexible, it kind of like that. Yeah.
Okay, I got it.
Yeah.
So you haven't tried to put that in the actual wound.
Yes, that would be super dangerous because it have to be in the more advanced laboratory.
Okay, so I guess you would need a special permit.
Yes.
Because it's a kind of a medical research or something.
Yes, and
Okay.
also when it have to use on human, it's used so many process to make it happen.
Okay. All right. I'm thinking if you want to test. So my question is, if you want to test the efficiency of this special fabric on how it heals a wound, how would you test it on a system that is very similar to the actual wound, but not the actual human wound? How would you do it?
Yeah.
Can you put it on a wound of a plant or something? I don't know. What?
We actually it more we have to use on bacteria. Like we have to study what bacteria that it got in the wound, and then we can use the extraction that we got, the antioxidants, and then we can taste is the bacteria is die or is it efficiency, but we cannot use on the actual wound because it would be wrong in ethical.
Oh, I see.
Yeah.
So you can study if bacteria come into contact with this special fabric, would it die or something like that? Okay.
Yeah, right.
I got it. Okay. Well, a good job on your
Oh, thank you.
my final question. Do you have a name for this special fabric. You should
Yes,
have what do you call it?
we
What do
we
you call
call
it?
we call right now is biofabric heel.
Well, it's not doesn't sound catchy. You should pick another name that sounds special and sparkling. Something that ready to be sold on the market.
We will consider that. But we still have to think about it. Yeah, but we definitely thinking the same thing. We need the catchy name so people won't be scared of it.
Yes, an anti-wound fabric, or I don't know,
Yeah, that's a
something
good
that
idea
interesting.
actually.
Okay.
That's a good
Oh,
idea.
okay, something that has a name by Buabok in it.
Oh, right.
ผ้าก๊อตบัวบก
That sounds good.
All right. Thank you for your answers.
Yeah, thank you.
All right, that was an incredible start to this half of the day. And now let us move to the next group, which is ISP10, a dopamine level detection sensor using metal nanomaterials on molybdenum disulfide and graphene oxide electrodes for chronic kidney disease risk assessment.
และงานพัชรนันท์เกียรติวัฒนกุล
All
Please
right.
give a warm welcome to ISP friends.
Good. You may start your presentation whenever you're ready, everyone.
This is our team now, or ISP1.
ISP10.
Okay.
10.
Can you see our presentation?
Can you see our screen?
Yes.
Yes.
Okay. Good afternoon. We come from Benjamin Graduate School, and today we're going to present you our project, a dopamine level detection sensor using metal nanomaterials.
Slow down.
Okay.
Half of the pace. Thank you.
Okay, so I'm going to restart again. Okay. Good afternoon. We come from Benjamin Graduate School, and today we're going to present you our project, a dopamine level detection sensor using metal nanomaterial on molybdenum disulfide and graphene oxide for kidney abnormality risk assessment. Oh, okay. Did you know that right now in Thailand, there are 1,062,756 people living with chronic kidney disease, and among them, 70,404 patients require urgent dialysis. Dopamine is a neurotransmitter that plays a key role in mood, motivations, and happiness, but it also acts as a hormone. In the kidneys, dopamine is essential for regulating kidney functions and maintaining fluid balance, which helps the kidney work efficiently. When dopamine levels in the body are abnormal, they are linked to several diseases, including neuroblastoma, pheochromocytoma, and chronic kidney diseases. Even factors such as eating food high in L-DOPA or taking levodopa medications or even being under long-term stress can also affect dopamine levels. This shows just how important dopamine is. If we could measure dopamine level in the body, we would be able to identify the risk of different diseases much earlier, which increases the chances of effective treatment and survival. Normally, dopamine detection is done using high-performance liquid chromatography or HPLC technique. However, this method takes a long time and requires very expensive equipment. By comparison, using modified electrodes make detection faster, more affordable, and highly sensitive. This is why our team is working on developing a dopamine sensor to evaluate the risk of abnormal kidney functions. With these innovations, patients can be more aware of their risks and take earlier steps to slow kidney deteriorations. And here are our objectives. 1. To develop material for electrode surface coating suitable for dopamine sensor applications. And second, to design and develop sensors based on composites of molybdenum disulfide and graphene oxide for dopamine detections.
And the next one is methodologies. For the part 1, synthesis of materials. First, we prepare molybdenum disulfide or MOS2. We mix ammonium molybdate and ammonium thiocyanate powders. Then we add the eye water, ethanol, and glycerol, and adjust the pH to 0.95 with hydrochloric acid. The mixture was put into a Teflon containers and heat at 200 degrees Celsius for 12 hours. After that, it was filled, washed with the eye water and ethanol, and dry at 80 degrees Celsius for 12 hours. And for the next one is graphene oxide or GO. We use humor method. Graphite was mixed with the hydrogen phosphate and phosphoric acid at 55 degrees Celsius for 30 minutes. Then
Could you speak close to the mic so I can hear it?
Then
Okay,
potassium
good.
permanganate was added. Ultrasonic vibration was used to separate graphite into graphene oxide sheets. After that, hydrogen peroxide and water were added. The yellow suspension were then washed with water and hydrochloric acid, pressed with ethyl ether, filtered through Teflon and dry at 30 degrees Celsius. And for the next one, part 2, preparation of the solution. We made a buffer solution by mixing disodium phosphate and sodium dihydrogen phosphate with the eye water. This gave buffer at pH 6.5 and concentration of 0.1 molar. And for the next one, the preparation of the dopamine solution. The dopamine solution is prepared in different concentration. It is 0.2, 0.4, 0.6, 0.8, 1.0, and 1.2 millimolars. We use the eye water as the solvent and dilute them with phosphate buffer. And for the next one, we also prepare the ruthenium nanoparticle solution at 1 millimolars using 0.5 millimolars sulfuric acid as the solvent. And for the part 3, electrode modifications, MOS2 and GO were mixed in 1:1 ratio with the eye water and ethanol. Then 1 microliter of this mixture were dropped on the electrode surface and left to dry overnight before use. And for the last part, part 4, dopamine measurement. To detect dopamine, we use 3 techniques. The first one is cyclic voltammetry to clean the surface of the electrode, then coronal amperometry, and the last one is differential pulse voltammetry. It is DPV. In the total, 3 electrodes were made to check the repeatabilities. Here I will show the result of the second electrodes as an example.
Next, we study the efficiency of dopamine detection. We study by examining the ratio of material used to modify the electrode, specifically graphene oxide to molybdenum disulfide at the ratio of 1:1. The electrochemical deposition time was set at 50 seconds with an applied potential of negative 0.5 volt, and the pH of the buffer solution was maintained at 6.5. So first technique we was used is cyclic voltammetry. We perform 20 cycles to test the electrode conductivity. This provides insight into electrochemical behavior of the material, indicating changes in the current flow. As the applied current increase, the resulting peak in the graph confirms that electron transfers occur during the oxidation process, demonstrating the electrode conductivity. Next, amperometry technique was employed to achieve electrochemical deposition using ruthenium nanoparticle to further enhance conductivity. A constant electrode potential was applied, and the variation of current over time was studied to determine the deposition rate of the ruthenium nanoparticle. After that, the electrode surface was cleaned using cyclic voltammetry by 10 cycles in phosphate buffer solution. For the dopamine detection, the technique we used was differential pulse voltammetry. The optimized parameter for this technique are modulation amplitude we set as 0.14 volt and modulation time we set as 0.05 volt. Then the last is interval time we set as 0.25 seconds. So this technique was applied to measure dopamine signal at various concentration from a standard dopamine solution. By integrating the area under the peak, the detection efficiency for concentration was evaluated. It was found that all three electrodes exhibit high precision and accuracy, with an correlation coefficient of 0.99, indicating their reliability for further study. And next, the table summarizing the performance evaluate of three different electrodes. The experimental result we have studied is the electrode performance first, sensitivity, second, limit of detection, third, limit of quantitation, and the relative standard deviation. So the table was summarizing the performance of evaluate of different three electrodes. And the experimental results show that all three electrodes demonstrated excellent reproducibility as indicated by the limit of detection is 1.1987 micromolar, limit of quantitation is 3.8551 micromolar, and our electrode have high sensitivity at 12.451 micromolar, and the RT% is 1.95%, which is below the acceptable threshold of 7.3%. Therefore, our electrodes are suitable for reliable dopamine detection and can be used for further electrochemical study. Thank you.
All right, now let's move on to, I would like to invite Dr. Thawit Chittakan to a question and give some thought.
Yeah.
Thank
I
you.
would like to know that if your technique, if compared with the standard one, is using SPLC by limit of detection or the sensitivity, which one is better?
Well, our goal is to make a sensor that can be taken to anywhere. We didn't make it to replace the HPLC technique, but to be the alternative ways for people to choose to take a test.
But anyway, you have to compare with some technique or the normal way that they use.
Yes, I understand.
Yeah, and you have a chance to compare the result between both techniques.
We haven't done the comparison yet, but in the future, maybe.
Mm-hmm.
Invite Associate Professor
Oh,
Dr.
okay.
Hugh.
All right. Well, this project is heavily based on chemistry, and I am a physicist. And when I was in high school, I hated chemistry. So I do have a lot of stupid questions from a beginner point of view. Could you go to the introduction slide where you explain side by side the HPLC
Okay.
and the electrode method on the right? Okay, here. I didn't quite get what you were doing here. So you were developing some sort of electrodes, am I correct?
Yes, you are
That
correct.
you could just dip into a solution, and you can
Yes.
say how much of the dopamine is
Yes.
there. Am I correct?
Yes, you are correct.
Okay. So the next piece of the puzzle from what I'm listening is that you prepare many substances like molybdenum, graphene oxide, and ruthenium something. So could you tell me what are the role of these three items, molybdenum, graphene, and ruthenium? What do they do in detecting dopamine? Is my question not clear?
Yes, your question are clear.
Okay.
So we prepare the molybdenum sulfide and graphene oxide to coat the electrode surface to enhance the detections of dopamines. And for ruthenium nanoparticles, we use in the technique coronal amperometry to enhance the electrochemistry conductivity. Yes.
I have heard a biochemist say something about specificity, right? When you want to detect something, your method has to be specific to the actual agent that you're trying to detect. How do you know that these electrodes are only specific to dopamine, not something else?
So they can be detect another substance too, but as the result of the differential pulse photometry technique, we show that this electrode and modern disulfide and graphene oxide can detect the signal of the dopamine too.
Could you show me the graph that you can see the peak as you increase the concentration of dopamine here, right? So I can see here that if you put some dopamine in, you get the peak in the signal. Have you tried some other substance besides dopamine? Sugar, saliva, or caffeine or something like that? Do they get still signal?
Okay, we haven't tried to take a test about other substances, yes, but we have read about others like projects and paper that it also can detect other substances too. But for this project, we aim to just develop the electrodes for just detecting of dopamine.
Okay, so my last question is the following. To detect something biochemically, somehow your electrode has to detect something from dopamine, right? Maybe chemical signal or whatever. Can you tell me the physical process or biochemical process that actually the electrode is doing to the dopamine to get the signal from? Maybe I can rephrase my question. Physically, I think physically, what does the electrode do to the dopamine to get the signal out of the solution?
So first first technique is cyclic voltammogram. So we first to obtain the cleaning of the electrode first, and then we scanning from 0 to +1 and back to -1 volt. It is the process of oxidation process to occur in the positive direction. Impurity on the electrode surface are oxidized during the first cycle. So subsequent this cycle will show a stable and similar curve. And for the next technique is coronal amperometry technique. So this is work by applying the potential of -0.5 volt. So the nanoparticle of ruthenium will accept the electron from the electrode, and it's reduced the ruthenium chloride from the oxidation number is positive 3 into 0, which is deposited onto the electrode surface. And for
Okay.
the last
Are you done? I'm still waiting.
And after we have been coding the nanoparticle, we will be clean again in the cyclic voltammetry technique again for 10 cycle. And next in the last technique of our project is differential pulse voltammetry. So this technique we have been studied the relation of the potential applied and the current. So you can see that in each concentration, there are some peaks that are different. So in the lower concentration, they will have a lowest peak, and the highest concentration, we will have the highest peak. Show that our electrode can detect the dopamine solution.
Okay, thank you. So, I think my final recommendation for your presentation is that you have done a good job in presenting the details of your experimentations, the electrodes, and so on, but not enough big picture for a person outside of the field to understand what's going on. Maybe a chemist professor would understand what you're doing, but from a physics or a biologist standpoint, I think I find it difficult to understand. Only after I ask your question do I understand what's going on. Okay, so do try to put more of a big picture slide in your presentation. That is my recommendation. Thank you.
Thank you.
Okay, that was the end of this group's presentation. Now let's move on. Oh, sorry. Is ISP17 ready? Okay.
Let's move on to team ISP17.
Yep. ISP17 prosthetic heart valve positioning system for fluoroscopic guidance.
Represented by PSU International School, Thailand, and the researchers are Bunyanat Sally, Pannawit Sally, and Pirapan Vitya Sambur.
Yes. So you guys are welcome to start presenting whenever you are ready. Good luck.
Okay. First of all, I would like to say good afternoon, honorable judges. My name is Bunyanat Sally, and I'm here with my teammates, Pannawit Sally and Pirapan Vitya Sambur. It is our privilege to present our project with both of you, and we are incredibly grateful for the invaluable guidance of our advisors, Assistant Professor Dr. Chanan Gongkamun and Mrs. Prida Choksuliwong. So our work today focuses on a topic of growing importance in medicine, a prosthetic heart valve positioning system for fluoroscopic guidance.
So you probably know that this day X-ray is essential for diagnosis. But the more X-ray you take, the more effect to our health you get due to radiation exposure. And there are some people that suffering to this problem. These people is the patients with prosthetic heart valve. And in Thailand, it is increasingly 4,000 people. These people have to follow up every 4 to 6 months to check the valve function by fluoroscopy. This technique is a technique that continuously emits X-ray to create a video of heart valve motions by fluoroscope, which is a C-arm X-ray machine. The doctor must adjust the fluoroscope until they obtain a clear side view of the valve, which is the best visualization of valve opening and closing angles for checking up valve functions. But these days, this process is done manually by estimating the angles to adjusting the valve function, to adjusting the fluoroscope. So it prolongs procedure time and increase radiation exposure. So we have developed a system that can calculate the angle for adjusting the fluoroscope. And it can get a precise side view of the valve to reduce procedure time and minimize X-ray radiation. And minimize radiation exposure. It can enhancing efficiency and safety for both patient and doctors. And our objectives are first to develop a system for accurately calculating the coordinates of prosthetic heart valves, providing precise reference points for adjusting the position of fluoroscope during performance evaluation in post-treatment monitoring. And second, to minimize radiation exposure for patients and medical personnel during prosthetic heart valve performance evaluation in post-treatment monitoring. And next is our resource fluoroscope, prosthetic heart valve, image processing software, computer, and art studio for static, Visual Studio Code, prosthetic heart valve rotational model. And our resource for web application development are Streamlit, NumPy, Matplotlib, Pillow, OpenCV, and YOLO.
First, we have done data preparation and system design. Then we go to Shakespeare image processing. In this part, we have trained our own model for detective heart valve. We have 1719 raw images with 1927 valves. Then we split the data into 80-10-10 with 80% of raw image in a train set and do an augmentation process. So we have 69 O5 in total. So we use those images to train the model, and when it finished, we will fine-tune the model and check the improvement of model, that it is improvable or no. If it's improvable, so we train it again and again and loop this process until it's not improvable. That means the model that leaves the maximum of improvement. So that model we call it base model. We use base model testing with test sets. That is 10% of raw image, and we get a fail report. Next step is to detect heart valve from Shakespeare image by using base model from last part and convert the image to binary image using thresholding for segmentation. After that, we fit the ellipse and draw it with half transform and determine the required parameters. To find caudal, to find LAO and IO, we collect Y value from intersection point in YX plane and C from intersection point in CX plane and put them in equation LAO equal arctan absolute Z over X. And to find caudal, we use equation caudal equal arctan absolute C over X. In accuracy test, we create a phantom model represent to heart and heart valve and took a photo of posterior and anterior, posterior anterior view and lateral view and put it into a system. And the system will give us exact angle of valve and use them to compare with X and Y axis that we set in phantom model. We have timed the experiment for compare with system and we have timed the experiment for compare with system and compare to normal experiment with our system. This diagram shows normal experiment with our system that patient took a posterior chest lay and go in fluoroscope field with doctor that don't know the exact angular experience, and also the radiation can be exposure more than it should be. In this diagram, it shows the journal of patients that use our system. First, they took posterior chest X-ray, and in additional, we took lateral view chest X-ray and put them in the system. The system will give a doctor exact angle of patient heart valve that make the experiment spend less time and less radiation exposure. To validate accuracy of system, we let the doctor perform fluoroscopy and record, then compare with answer from the system. This is our prototype. You can see that it's very easy to use and use very less time.
So now let's move on to our results. Start with the performance of our detection model. On this slide, you can see our precision confidence curve. This graph illustrates the relationship between the model confidence threshold and its precision. As you can see, the curve is very high, indicating a strong performance. We achieved an average precision of 1 across all classes at a confidence 0.886, which means it's like 88.6%. So what and this means is that at high confidence level, and our model was perfectly accurate. Next is LAO angle calculation accuracy. So if you can see the plot, the blunt element plot compare the angle from our automated system or our system to actual angle that we set on our physical model or phantom. And below the graph, as you can see, is ICC, is interclass correlation coefficient, and in LAO it is 0.994. So it's within the 95% IC, indicates a very high degree of reliability and agreement between our system values and the true values. And the mean difference is minus 1.07 degree, mean our system calculated values are on average just slightly lower than actual values. It is very small. So in clinical term is insignificant difference. At the same time, in caudal is another angle that a physician would adjust the first scope. So in the same way, the interclass correlation or ICC fell in 0.994. So it's fell in 95% of ICC is indicate a very high degree of reliability and agreement. So, and it is a small difference in mean difference. So both results of LAO and caudal angle analysis, the side difference we see are within an acceptable range for clinical use, proving the system is trustworthy for guiding the fluoroscope. And next is fluoroscope adjustment time using prosthetic heart valve positioning system. And for context, we asked doctor who performed this procedure what their typical adjustment time is. They told us that without our system, they spend 10 to 15 minutes in real patient. But when they use our system with our phantom, they adjust just 30 seconds to 90 seconds. And next is the table of relations of cases comparing physician adjusted angled and system calculated values. As we mentioned, our experiments will let real physician to do real clinical practice. So in the green box is physician adjusted angle, and in the blue blocks is system calculated angles. And the results are very promising. The difference for LAO angle are very small, of only about 1 to 7 degrees. and the caudal differences are all below 1 degree. So these results show that our system calculation are very close to angle that a physician would find in routine clinical practice, while doctors typically adjust the fluoroscope visually without recording specific angle. But our system provides precise and reliable outputs. In conclusion, first is our model reliably detects valves in X-ray images. Second is our system precisely determines the fluoroscope working angles in both angles in LAO and caudal. And 3 is provide time reduction. Fluoroscope adjustment takes like in traditional way is take 10 to 15 minutes in patient, but using the system with simulator or our phantom reduce it to 30 to 90 seconds, saving 85 to 96.7% of the time. And it also means patient and staff exposure decreased by 85 to 96.7 as radiation dose is direct proportional to fluoroscope adjustment time. And the last conclusion is our system is highly effective and suitable for real-world hospital application and improving clinical outcomes. Our recommendation and our challenges is first is experimental design is challenging because the system must be tested on real patient. And the second is limited of project time prevents testing the system on real patients. But despite we also have future works, so we will do an experiment on real patient and use in hospital. As follow, we will develop as an application for ease of use by medical personnel. And this is our references. Thank you.
All right. Now, next, we would like to proceed to questions and recommendations from one of the judges. May I invite Associate Professor Dr. Tipanit Chasio, please.
Okay, test. I do have real question, but let me begin with a simple question first. Could you go to the slide number 3?
Great. Okay.
And in that slide, you mentioned something about 4,000 years something, but I didn't get yet this one. 4,000 years in Thailand. What was that?
It is 4,000 patient that has a prosthetic heart valve treatment.
Oh, okay.
Per year.
I got it. 4,000 patients per year. Okay. All right. So in this project, I was gonna give you a bell, but let me first make sure that I get the correct picture. Could you show me some slide toward the end where you built your own artificial heart for imaging?
Sorry. Can you repeat that again?
I remember it was a slide toward the end where you make this prosthetic heart on your own. It was made of a PVC cylinder,
Yes.
Do you mean this
something.
one?
No, show me the slide so I can see it
Okay.
better.
Okay.
This one?
So you built this one on your own.
Yeah,
Am I correct?
Yes.
And you took images, and then you feed that images to your AI model. Have you done that? What did you do with this PVC that you made?
Okay. Inside the PVC is a real plastic hard valve, and we
Okay.
use it just for test the accuracy of the model.
So if you can see at the right hand side of the slide, it is this that we took from fluoroscope.
Okay.
So we take it under the fluoroscope and take the image of it for testing accuracy of angle calculation of our system. Did you get it?
Okay, so you did not take this data from the internet, but you actually built your own heart and then took images and performed calculation. Am I correct?
Yes.
Yes.
Okay, that's why you deserve a ring, okay, a belt, because you are the first AI project that built your own data to test with your model instead of downloading it from the internet. Okay, because
Oh, sorry. It's my misunderstand. We
okay.
use for testing the accuracy, but the data we use for training our model is data from a hospital, Songkran Nakhrai Hospital.
Anyway, so you tested it with the real model that you made yourself.
Yes.
Okay. You still got a bell for that, because in AI research, data is the key to the whole thing, and you're supposed to have experience about how to actually make your own data as opposed to just downloading it from the internet. Could you go to the last slide where you show us how much time you have saved? Okay, this one, this time reduction is about 10 times faster, because you would take about 10 minutes in the actual machine, but with your system, it take only 90 seconds. So that's about 10 times faster. Okay. I guess when you want to test it on the real people, there's a lot of regulation and permits and all the process that you have to go through to get that. And I don't think the laws is going to be any easy or anytime soon. So I think overall, I love the project. That's my reaction. Okay, thank you.
Thank you so much.
For me, I would like to know that before you build up the model heart, how you get up with the idea of this have to be designed with the dimension, or what material that you use, like something like that.
All right.
You get the idea from whom, or from by yourself?
We get this idea when we have a discussion with.
I would like to know that.
You would like to know.
With what, Dr. Chanon, or?
Yeah. Yes, it's like on our discussions with Dr. Shannon and Ajahn Pab. Yes. So when first we decide to do an experiment, so we discuss a several of like options, but this option is from Ajahn Pab. Dr. Pam.
Dr. Pam, he is working in with faculty?
Yes, he also working in data data
Data analysis wait.
and data innovation in the same faculty in medical faculty as Dr. Chanun and in the same department. But he is biomedical professor.
And which lab that you use?
Which
Oh, okay. Biomedical professor. Okay. Very good job.
Thank you.
Excellent, excellent.
Thank you.
Why don't you paint it in red instead of blue?
Paint it in red.
Well, it's a heart, isn't it? So
Oh, Well, I think it's a simulator. So I think the color is not in the.
It's not on the color because when we take it in a fluoroscope, it's just black and white.
Yes.
okay, thank you. I was just kidding with you. That's all.
Oh yeah, I see.
All right, and I believe that's the end of this presentation. While I agree with Professor Shashiro that the model is supposed to be red, we should move on to the next theme, which is ISP15, preparing of biohacks based on palm oil, polio, with curcumin and Centella asiatica extraction for burn wound healing.
Please give a warm welcome to Team ISP15.
On your camera. Good afternoon. Can you hear us clearly?
Yes.
That's fine. Thank you. Good afternoon. My name is Paraisan Tamano.
My name is Pakapana Sakit.
And it's a great pleasure to be here today to share our presentation on preparing of biopatch based on palm oil polymer and curcumin and Centella asiatica extraction for bone healing with Associate Professor Nina Satang as an advisor.
I think you're too excited. Perhaps you could slow down.
Wound healing patch are synthesized from petrochemical-based polymers, which were concerned about environmental impacts and long-term sustainability. In our research, we explored the use of palm oil as a renewable resource to synthesize bio-based material for burn wound healing applications, offering a more sustainable and environmental-friendly alternative. Wound healing process is often slow and difficult, especially when the wounds are exposed to infection, dehydration, or repeat stress, which is why patches are essential to protect wound and support faster recovery. And to boost healing, we add natural extract curcumin, which reduces inflammation and protects against infection, and Centella asiatica extraction, which stimulates cell growth and accelerates wound closure. Our objectives are threefold. First, to synthesize biopolyol from used palm oil through a thionucleic reaction. Second is to develop polymer polyurethane based on this biopolyol as a sustainable alternative to petrochemicals. And third is to prepare biofilm patches enriched with curcumin and Centella asiatica extracts to enhance wound healing. In this study, refined palm oil was subject to a thionucleic reaction, targeting the double bonds in the fatty acid chains. A photoinitiator was added and the reaction mixture was exposed to mild heat under UV radiation.
This efficient process successfully incorporates hydroxyl groups into a palm oil molecule, yielding functional biopolyols suitable for subsequent polyurethane synthesis. We then form waterborne polyurethane from modified palm oil, catalyzed Chilic cylinder. Nitrogen was bubbled into this solution during the stirring with a balloon, and then we add curcumin extract or centella asiatica extract or non, solute with deionized water dropwise and mix again. The solvent was evaporated using vacuum evaporation, and herbal extract containing waterborne polyurethane formulation were developed. Finally, waterborne polyurethane mixture were cast and dried in a mold, faced at room temperature for 48 hours, followed by hot air oven drying for 24 hours to result in flexible earth-filled bio-based patches. In this experiment, we incorporate curcumin and centella asiatica extracts separately at 10%, 15%, and 20% by weights to observe whether each concentration could successfully form a uniform and well-defined theme. We also test the theme without any extracts to analyze their chemical structures using NMR and FTIR and to evaluate their biocompatibility through a cytotoxicity assay at the Faculty of Science, BSU Hat Yai. For the theme containing extract, we analyze their chemical structure using FTIR and evaluate their wound healing potential through a wound healing assay.
Okay. The property of vampire molecules were analyzed by proton NMR and FTIR. NMR shows a decrease in double bond peaks after the tile reactions with a conversion of 98%. New peaks confirm the formation of hydroxyl and tile groups. FTIR supported this, showing bands for hydroxyl, carbon, and sulfur station regulations. And waterborne film polyurethane film and waterborne urethane films containing herb extracts were cast. The plain films appeared like yellow, while film with curcumin and centella asiatica attack became progressively deeper yellow as the extract content increased. The FTIR spectrum of waterborne urethane and waterborne urethane with centella asiatica extract show similar absorption bands with film exhibition peaks at nitrogen, hydrogen station, and carbon oxygen station. The film with centella asiatica attracts also show a new peaks over here. Yes. Corresponding to hydroxyl groups, similarly, the film with curcumin display absorption bands characteristic of both waterborne urethane and curcumin extract. The palm oil-based bell film maintains cell viability above 69%, demonstrating a non-cytotoxic effect on human dermal fibroblasts, indicating its safety for potential wound healing applications. In the wound healing assay, centella asiatica and turmeric extract at 1% dilution significantly promotes closure. In normal oral keratinocytes spontaneously immortalize cells. Centella asiatica at 50 to 20% and turmeric at 15% show the strongest effects, nearly achieving complete wound closure, highlighting their potential for oral tissue. And in human dermal cells, centella asiatica and turmeric extracts significantly enhance wound closure. Centella at 20% was the most effective, nearly achieving complete healing, followed by turmeric at 15% and centella at 15%. These results highlighting the potential of this extract for promoting skin repair. And in this study, bell-based polyurethane film containing curcumin and centella asiatica extract were successfully prepared. The modified use palm oil-based bell showed 98% double bond conversions, and the resulting waterborne urethane film had good dispersion without phase separations. Cytotoxicity tests in human dermal fibroblast cells indicated over 69%, confirming the film are safe. Centella asiatica and turmeric extract promoted wound healing, with centella asiatica at 20%, showing the strongest effect. highlighting their potential for biomedical patch and skin repair applications. Thank you for your attention. Thank you.
I will be pleased to address any questions and comments you may have.
Okay, may I invite Associate President Dr. Thawat to advise and ask questions.
Okay, thank you. It seemed to me that this project you create a new material, WPU, right?
Water-borne polyurethane is a polyurethane that created by a dispersion through the water. It is one of the techniques that we use to synthesize normal polymers.
Okay. And why you choose the turmeric and the Centella asiatica together?
Because each of these extraction has special effects on wound healing, which curcumin can reduce inflammation because it has a paper that say that it can anti the bacterial infection, and Centella asiatica also common use as cosmetics for stimulate cell growth and soothing the skin. So it is suitable for applying in the wound, in the burn wound healing.
So now your project can create the WPU film, right?
Yes. Yes, we can
and you
create the water-borne
register,
polyurethane successfully. Pardon?
Do you plan to register or to patent this material?
I can't hear clearly. Could you please raise the volume, please?
Because this is a brand new material.
Yes.
You choose register or to patent this product.
We choose to register these products as alternative for petroleum-based polymers that create in normal marketing wound healing patch. Because polymers, as you know, that it raises our concerns about environmental sustainability, because it can cause a lot of pollution. Yeah.
Okay, that's all for now.
Thank you very much.
Okay, so this patch,
Yes.
I am hearing echo.
Pardon?
There's an echo in my voice.
Yeah.
Somebody is not turning off the mic.
I can hear you. I can hear you.
ISP15, please mute your microphone. It should help the problem.
Test. Okay, now the echo is gone. It's coming back. It confuses me.
ISP15, please turn off your mic.
Okay.
Test. Still here. That's fine. I'll try to speak. Let's see. So this patch, it heals well and it smells good. Am I correct?
It actually doesn't smell good, but it can heal well, but it doesn't actually smells good.
Why did you put cumin in there?
Because we actually put the extraction in there, but the extraction odor cannot resist the smells of the sulfur that we add into a thiol.
Oh,
So
okay.
it's gonna smell like sulfur anyways.
Okay, so what I like about your project is that
Yeah.
you study using a very deep technique like spectroscopy. So I want to ask just to test your understanding. Can you explain what is FTIR?
FTIR is the techniques that we use the spectra of the protons to, as I understand, to vibrate the bonds of the molecules that we have, and then each bond and each bond in each molecule will vibrate will give out the different wavelengths, and we can
But we need to make sure that
that we can difference the bonds or the bonds that we want to see from the wavelength, from the different wavelength, because it have a specific wavelengths come out.
and we have IUP as carbon hydrogen that make sure that we can
Incorporate the extraction into the waterborne polyurethane.
Okay. Well, it's not, your explanation is not too bad. Actually, the molecules are vibrating, just like music instrument. They are vibrating all the time. And we can observe that vibration using this technique called FTIR. And each vibration is a signature of each molecule. So by looking at the frequencies or the wavelength the same, you can identify which molecules we're looking at by looking at the signature of the frequency that they're vibrating. Okay, that's FTIR. Another thing I want to ask is if you go to slide number 13, please. Very good. So one of the things that you are presenting are the images on the right, in rows and columns. Could you explain to me what I'm looking at? The dots on the images, what are they? What do they mean? Zoom in as close as possible if you can, and explain to me what I'm looking at here. Do you see the grains of these images? And somehow, if you go from 0 hour to 24 to 48, something happens. What has happened here? I can't hear you.
Please turn on your mic. Your mic is muted right now.
Okay. You see the cells. You see the cells, and this is the cells we have it on a plate, and the middle and space is the space that we put the cells out. So there's a blank space, and we need to explore the effect of the wound healing effects from different percentage of
I didn't get it, but so in the middle you have a void, empty area.
It's the void blank areas that we don't have cells on it. And
Okay.
But at the time scale to 24 hours, we can see that the extraction caused the cell accelerate the cell growth and moving into the middle.
Okay, that's why
So
it's healing. Okay.
yes, and that's the sign for the cell is healing. And as we can see in Central Asia, 20% it is our best. You can see that only just 24 hours is healed almost completely.
Okay. So my recommendation for your future presentation is following. For what I see, these images are gold that you can tell a story behind it. Tell the audience what happened from the left to the middle and to the right. But you just show me in the beginning and then forget about it. That is not the way you would present the data. Okay, so next time present the data by telling a story of images as opposed to just numbers.
Okay, thank you very much.
That's all I have for now.
Yeah, thank you very much for your comments.
Now that should the end of this presentation. It's now the last but not least theme, ISP23. Yes, the effect of biofermented water on the growth of morning glory seedlings.
They are presenting by Chawat, Vityakan School Thailand, and the researcher are Thanatip Thong Taiwan, Ekapop Maniwat, and Wathaya Choi.
Yes.
Please give a warm welcome to team ISP23.
Please give them a moment. We are slightly ahead of schedule, so they probably are not aware that we have reached their turn to present.
You
Well,
can start when
ISP23.
ready.
Yes, you may start whenever you're ready.
Good luck.
You may start whenever you're ready.
Good luck.
Good afternoon, ladies and gentlemen. We are students from Chodyakan School. My name is J.D. My name is Thiratip Thongthoi.
My name is Ekapop Manirat.
Today we are present our project and tested the effect of fermented water on the ghost of morning glory sibling.
At present, Chawabzia Khan School has a large amount of leftover food waste from food preparation in the school kitchen. The project team recognizes the problem of food waste being discarded without benefit and therefore saw where to make use of it. Through their study, they discovered that the food waste can be fermented with molasses to produce hormones that stimulate the growth of water morning glory ceiling. The reason for choosing water morning glory ceiling in this research is that there are an economic of widely cultivated by farmers as they require only about 2 weeks to grow before everything. Therefore, the project team carried out this study to develop a fermented solution formula that can promote the growth of water morning glory ceiling. Objective: firstly, to prepare fermented bio extract from fruit peel. Secondly, to study and identify the bio fermented formula that most effectively promote the growth of morning glory ceiling.
Day 3 parts of methodology. Buy food peel sample banana, pineapple, and watermelon from the food vendor in the cafeteria of Shodiakan School. Part 2. Preparation of biotic solution. Blended food peel with molasses 7 bio-fermented formula were prepared. Formula 1, pineapple, molasses 3:1. Formula 2, watermelon, molasses 3:1. Formula 3, banana, molasses 3:1. Formula 4, pineapple, watermelon, molasses 3:1. Formula 5, pineapple, banana, molasses 3:1. Formula 6, watermelon, banana, molasses 3:1. Formula 7, pineapple, watermelon, banana, molasses 3:1. Part 3, dilution of fermented solution with water 2:1, 1:1, and 1:2 by bio-fermented solution 2 ml water. Part 4, raw observation of morning glory seedling. Measure raw result will compare a loss or dilution ratio to determine which formula and dilution level for the best raw result. This slide shows the result of the study. The result of preparing fermented bio-extract from food peel, jolt, and this table. Comparison table between fermented solution before and after fermentation and pH value. The pH value of the bio-fermentation are true for which is slightly acidic. This page presents the result of the study on bio-fermented formula affecting the growth of water morning glory seedling at a 1:1 ratio. This ratio is shown because seedling grows better at 1:1 compared to 1:2 and 2:1 ratio, as measured by stem height. The picture shows the height of water morning glory seedling in all formulas after dilute with water and a 1:1 ratio. It can be seen test formula to have the tallest ceiling while Formula 3 has the shortest among all formulas. Discussion and conclusion. Firstly, this experiment studied the effect of biofermented solutions from food spill on the growth of morning glory ceiling. It was found that all formulas as acidic properties, pH around 3 to 4, and the acidity increased with longer fermentation time, with the pH stabilizing at around day 30. Secondly, the 7-day experiment found that a 1-to-1 diffusion of the biofermented solution resulted in the greatest height of morning glory ceiling, while the undiluted solution led to poor growth. This is consistent with the study by Siraj Gavikiao, which reported that plants grew well when the biofermented solution was appropriately diluted. Thirdly, when comparing the 7 biofermented formula diluted as a 1-to-1 ratio, Formula 2 promotes the best growth of morning glory seedling as watermelon greens contains plant hormone, especially gibberellin, which stimulates germination and stem elongation. In contrast, Formula 3 produces the least growth. Additionally, the nutritional content of the seedling growth, which is formula, should be analyzed to ensure their benefits. Thank you.
Right, that was a really great last presentation for today. I would like to invite
Associate Professor Dr. to please.
Sorry, I would, Dr. Tawat Chittakan, we would like to invite you to
Advice
give
and ask
advice and comments and ask some questions.
Okay. From your result, you mentioned that the recipe number 2 is the make the morning glory go quite well. Can you explain why?
ไม่คนหนึ่งช่องว่าทำไมมันต้องมีหมายชุดต้องจำไม่ได้นี่
because watermelon greens contains hormone called gibberellin, which promotes stem elongation, seed germination, flowering, and flower development.
I think you should identify the microbe or the type of beneficial bacteria that exists in the recipe number 2 that you are prepare, because number 2 is comprised of watermelon peel and morass. And the least effective one is formula 3, is comprised of banana peels and morass. And I think the microbe should play the important role for the morning glory, for the growth of morning glory. And what is your future plan after this? Your group have discussed together what should we pursue this project to go on or stop.
Again, please.
What is your future plan?
Future plan
For this project? Okay, so think about this project that because you have some result or some knowledge about
this project can be further developed in several ways. First, the experiment can be testing the bio fermented solution on other type of vegetable or crop to compare the effect. Second, the nutrient composition of the solution can be analyzed to identify the excess substances responsible for plant growth. Third, the optimal dilution ratios can be refined to maximize growth efficiency. Finally, the result should be obtained in sustainable or community farming, reducing chemistry from use and promoting. Thank you.
Okay, thank you.
Okay.
Professor Shashio, do you have any questions for them?
Okay. I still have no idea what the morning glory seeding is. What is the Thai name for it? How do you call it in Thai?
It's ต้นกล้าผักบุ้งอาจารย์
ผักบุ้ง
ใช่
ครับผักบุ้ง
Okay. Now I got it. Okay. So, which bring me to the next question. Why do you why do you want to enhance the growth ofผักบุ้ง? Why do you pickผักบุ้ง to study?
Because through their study, their development, that's the food waste can be because
Yes, that's okay. Take your time. Is that because there's a lot ofผักบุ้ง in your school that you want to grow? Perhaps you want to grow moreผักบุ้ง to put in your ส้มตำ
Yes.
So which is the reason that you pick this particular plant to study? I can hear you, or you're thinking about the answer. Should I go to the next question?
Can I answer in Thai?
Sure. Yes, you can.
เพราะว่าต้นหอมผักบุ้งมันมีราคาแพงค่ะ แล้วก็มันเป็นคนรักสุขภาพส่วนมากจะนิยมทานต้นหอมผักบุ้งค่ะแล้วมันก็ปลูกง่ายด้วยค่ะ มันแบบใช้เวลาไม่ได้กี่วันค่ะ
Okay. Now I got it. I understand the reason. Now I want to ask about the mechanism in which this fermented solution can enhance the growth ofผักบุ้ง. What is happening here? So you make a certain fermented juice, I believe, and you put that solution into or feed it toผักบุ้ง. Why does it grow better?
Again.
Well, let me see. I guess as human being, we drink a juice, right? A human being, we drink juice and we feel better. But for plant does not drink juice. So I don't think when you put this fermented solution from bananas or something like that, it would make any difference. Do you understand my questions, or should I rephrase that in Thai? While you discussing the answer, I can rephrase the answer in Thai, the question in Thai. ปกติคนเราสามารถกินน้ำผลไม้ใช่ไหม มันมีสารอาหารอยู่ภายใน มีน้ำตาล แต่ว่าพืชเนี่ย เช่นผักบุ้งเนี่ย มันไม่ได้กินน้ำผลไม้แล้วอยู่ได้เนี่ย มันกินสารอาหารพวกโพแทสเซียม ไนโตรเจนต่างๆ เพราะฉะนั้นคุณเอาน้ำหมักผลไม้ไปให้มันกิน ผมก็ไม่นึกว่ามันจะมีประโยชน์อะไร คุณลองอธิบายสิ
คือที่ผัก ที่ต้นหนผักบุ้งโตขึ้นได้ เพราะว่าจากฮอร์โมนในเศษผลไม้ครับ ไม่ใช่จากอาจจะไม่สารอาหารอาจจะมีผลครับ แต่ว่าฮอร์โมนพืชตัวจิบเบอรีนน่าจะมีผลในการเติบโตมากกว่าครับ
Oh, okay, so now I got it. You are hypothesizing that the actual hormone in the fruit enhances the growth of pakbung. Okay. Well, I'm guessing in the future you can make it a big scale processing. You can use a very big fruit waste and then dump it into pakbung in your schools, make it grow a lot faster. เอาเศษผลไม้จากร้านขายผลไม้ขนาดใหญ่เป็นตันๆนะแล้วก็มาเทคุณเห็นข่าวเวลาที่ราคาผลไม้มันตกไหมแล้วก็มีคนเอาไปเททิ้งเพื่อประท้วงรัฐบาลคุณก็บอกว่าไม่ต้องไปเทมาทางนี้แล้วก็มาเทใส่ผักบุ้งของโรงเรียนคุณโอเค that's all I have for now. Thank you.
Thank you.
Thank you.
All right, and that was the last team for today. Thank you so much, everyone, for participating, putting all your effort, so much of it into these presentations.
So we got our project today, and I'm just going to give you a fear of STEM is looking bad.
Yes, it is. I'm sure that everyone is excited about the results, but we will not be announcing it here, not now. But the success of this event would not have been possible without the unwavering support, diligence, and expertise of our judges and committee members, who brought a wealth of knowledge and experience and have played a crucial role in ensuring the smooth and fair execution of this event. We would like to extend our heartfelt thanks to each and every one of you.
Thank you to the organizing team, the participants, and the entire ISP community. Success.
Thank you.
Thank you.
That is all of the team. ครับโอเคอาจารย์ครับเดี๋ยวนักเรียนจะไปรวมต่อห้องรวมนักเรียนจะไปรวมต่อที่ห้องรวมตอนนี้ก็
ครับดึงไปด้วย
อ๋อได้เลยครับเดี๋ยวดึงอาจารย์ไปเด็กๆเดี๋ยวเอาอาจารย์เข้าห้องรวมด้วยทั้งสองท่านครับผมเดี๋ยวให้ทีมงานดึงเข้าไปนะก็ในส่วนอาจารย์สามารถส่งผ่าน Google Form ได้เลยขอบคุณมากๆเลยนะครับผม
ครับสวัสดีครับ
ขอบคุณครับ